about to begin.
Recording.
Please have seated, turn on your camera, and mute the microphone. It's been a great honor for me. I am Sylvia Yolanda Christie to be here and welcome each and every one of you in this virtual conference. Before we proceed the program today, we would like to express our sincerely gratitude to the Excellency Rector of Universitas Negeri Semarang, the Excellency All Vice Rector of Universitas Negeri Semarang, the Excellency Dean of Engineering Faculty, the Excellency all of the Deans of Universitas Negeri Semarang, the Excellency the Director of Postgraduate of Universitas Negeri Semarang, the Excellency all of the head of LPPP and LPPM Universitas Negeri Semarang, the Excellency the Vice Dean and Head of Department of Engineering Faculty, and the distinguished keynote speakers of the conference, Dr. Enomoto Hiroshi from Faculty of Mechanical Engineering, Institute of Science and Engineering, Kanazawa University, Professor Shushun Liu, PhD, from National Yunlin University of Science and Technology, Dr. Junaida Jai from Faculty of Chemical Engineering, University Technology Mara, Professor Dr. Warodiah Pitarengga, STMT, from Department of Chemical Engineering, Faculty of Engineering, Universitas Negeri Semarang, and the Honorable all invited audiences and participants of the conference. On behalf of Engineering International Conference Committee, we would like to extend a very warm welcome to all of the audiences and participants. The Engineering International Conference is an annual event conducted by Engineering Faculty Universitas Negeri Semarang.
Terletak di kampus utama Universitas Negeri Semarang, Fakultas Teknik merupakan fakultas kelima sepanjang berdirinya kampus Universitas Negeri Semarang sebagai rumah ilmu yang menyelenggarakan pendidikan tinggi dalam ilmu pendidikan teknik, pendidikan vokasi, dan ilmu rekayasa. Fakultas Teknik semakin meneguhkan posisinya menjadi kampus besar perguruan tinggi yang menghasilkan insan cendekia yang kreatif, kompetitif, dan inovatif, baik dalam bidang akademik maupun non-akademik, untuk kemajuan bangsa dan masyarakat dunia dengan berbagai penghargaan dan capaian prestasi dalam skala nasional maupun internasional.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Fakultas Teknik Universitas Negeri Semarang mempunyai visi menjadi fakultas yang berwawasan konservasi dan bereputasi internasional. Fakultas Teknik menyelenggarakan pendidikan, penelitian, dan pengabdian kepada masyarakat dalam bidang pendidikan teknik, pendidikan vokasi, dan ilmu rekayasa. Kami terus berupaya dan berkomitmen menghasilkan lulusan unggul yang beriman, profesional, serta mampu bersaing dalam dunia kerja dan menjadi unggul dalam bidangnya untuk membangun bangsa dan berguna bagi semua masyarakat dunia.
Fakultas Teknik Prestatif.
Fakultas Teknik Kreatif.
Fakultas Teknik Profesional.
Selamat datang di Fakultas Teknik Universitas Negeri Semarang.
Fakultas Teknik Universitas Negeri Semarang memiliki 5 jurusan yang di dalamnya terdapat 14 program studi, 9 program studi kependidikan, dan 5 program studi non-kependidikan. Jurusan Teknik Sipil memiliki 3 program studi, yaitu Program Studi Pendidikan Teknik Bangunan, Program Studi Teknik Sipil, dan Program Studi Teknik Arsitektur. Jurusan Teknik Mesin memiliki 3 program studi, yaitu Program Studi Pendidikan Teknik Mesin, Program Studi Pendidikan Teknik Otomotif, dan Program Studi Teknik Mesin. Jurusan Teknik Elektro memiliki 3 program studi, yaitu Program Studi Pendidikan Teknik Elektro, Program Studi Pendidikan Teknik Informatika dan Komputer, dan Program Studi Teknik Elektro. Jurusan Pendidikan Kesejahteraan Keluarga memiliki 4 program studi, yaitu Program Studi Pendidikan Kesejahteraan Keluarga, Program Studi Pendidikan Tata Boga, Program Studi Pendidikan Tata Busana, dan Program Studi Pendidikan Tata Kecantikan. Jurusan Teknik Kimia memiliki 1 program studi, yaitu Teknik Kimia. Masing-masing jurusan didukung dengan laboratorium belajar yang berorientasi industri sebagai sarana pengembangan kemampuan-kemampuan akademik mahasiswa untuk siap terjun dalam dunia kerja. Fakultas Teknik Universitas Negeri Semarang memiliki 14 program studi yang sudah terakreditasi baik dan unggul. Berbagai prestasi telah ditorehkan oleh mahasiswa Fakultas Teknik Universitas Negeri Semarang di kancah internasional, diantaranya Finalist of Cell Eco Marathon Asia, Finalist of Same Car Competition Jerman, gelar karya Fakultas Teknik Universitas Negeri Semarang, the second winner of International High Early Strength Self-Consolidating Concrete Cube Competition, yaitu lomba beton tingkat internasional, gold medal dalam event kompetisi penemuan dan inovasi internasional Sahasak Nimafum di Sri Lanka. Prestasi terbaik Fakultas Teknik Universitas Negeri Semarang yang lain diantaranya Paper Mob terbaik Fakultas Universitas Negeri Semarang 2019, rekor muri Paper Mob virtual pertama di Indonesia. Pencapaian ini menghantarkan Fakultas Teknik Universitas Negeri Semarang sebagai fakultas yang memiliki kredibilitas baik dan unggul. Organisasi kemahasiswaan yang berada di Fakultas Teknik yaitu Lembaga Kemahasiswaan di tingkat fakultas dan jurusan, Badan Semi Otonom, dan Wadah Aspirasi.
Today, we have a very full program ahead of us. We would like to outline briefly the course of the conference. Firstly, we will have opening. Second one, there will be a speech from the chair of the 10th Engineering International Conference, Dr. Prima Astuti Handayani, STMT. Then the next speech will be delivered by Director of Universitas Negeri Semarang, and also will officially open the conference. Next, we will get to the main agenda. There are presentations from 4 keynote speakers. There are Dr. Enomoto Hiroshi, Professor Xiuxun Liu, PhD, Dr. Junaida Jai, Professor Dr. Warodiah Pitarengga, STMT. And after having a break, we will continue to the parallel session. Then the last, we will have closing and announcement for the best presenter. So we urge for the audiences to always stay in the room. So ladies and gentlemen, without further ado, let's proceed to the first agenda. Let's now get down to the business. Ladies and gentlemen, we are going to sing national anthem, Indonesia Raya. For all the participants, please stand up. Audience, please be seated. Thank you. The Excellency, our distinguished guests, ladies and gentlemen, let's open this conference by saying Basmala. Thank you very much. Then it is now our pleasure to invite the chairman of AIC 2021, Dr. Prima Astuti Handayani, STMT, to give us an opening speech.
The Honorable Rector and Vice Rector of Universitas Negeri Semarang, the Honorable Dean and Vice Dean of Faculty of Engineering Universitas Negeri Semarang, the Honorable Dean of Universitas Negeri Semarang, the Honorable Keynote Speaker, Associate Professor Junaidah J. from School of Chemical Engineering, College of Engineering, Universitas Teknologi Mara. The Honorable Keynote Speaker, Associate Professor Unamoto Hiroshi from Faculty of Mechanical Engineering, Institute of Science and Engineering, Kanazawa University. The Honorable Keynote Speaker, Professor Porodiah Pitarengga from Department of Chemical Engineering, Faculty of Engineering, Universitas Negeri Semarang. The Honorable Head of Department of Faculty of Engineering, Universitas Negeri Semarang. The Honorable all the participant distinguished delegates, the expert and academic of Engineering International Conference EIC 2021. Assalamualaikum warahmatullahi wabarakatuh. Good morning and may peace be upon you all. Dear colleagues, opening my speech praises all to Allah for His blessing and mercy that allow us to be here today, 23rd September 2021, attending the Engineering International Conference EIC 2021. On behalf of committee, I am delighted to welcome all the participants, distinguished delegates, the experts and academic from around the world to the 10th EIC this year. The 10th EIC 2021, organized by Faculty of Engineering, Universitas Negeri Semarang, is conducted to support conservation and international reputation vision. Similar with our previous conference of EIC 2020, EIC 2021 will be held online via webinar due to the impact of the coronavirus disease, COVID-19, around the world. 114 participants from Qatar, Malaysia, Taiwan, Thailand, and Indonesia are joined in EIC 2021. Distinguished guests, as an annual conference in engineering, EIC provides a highly competitive forum for informing and reporting the latest development of concept and application of green technology. The parallel session of the conference can be the place for presenters from the engineering area to share their research, exchange new idea, information, and application related to the theory, design, development, implementation, testing, or evaluation in the area of green technology. The concept of green technology can facilitate the goal of keeping the environment intact and improving it for civilization to survive. This conference focuses on the goal of green technology, which are becoming increasingly important for ensuring sustainability, provide a different perspective of green technology in the sector of energy, material, production, IT and control, building and construction, as well as waste management and transportation. This conference is expected to bridge the gap between the scientific community and policymakers. The accepted and presented paper after peer review will be published in Journal of Advanced Research in Fluid Mechanics and Thermal Science Scopus Index, Asian Journal of Chemical Engineering Scopus Index, IOP Conference Series, Earth and Environment Science Scopus Index, Jurnal Bahan Alam Terbarukan Sinta 2 Index, Jurnal Teknik Elektro Sinta 2 Index, and ISSN International Conference Proceeding. I would like to thank the Dean and Vice Dean of Faculty of Engineering, the keynote speaker, reviewer, and organizing committee for their hard work. I also would like to express our gratitude to all publisher, partner, sponsor, and individual who have contributed to the event and success of this conference. Finally, welcome to EIC E-Conference 2021, and we wish you a fruitful conference. Thank you very much and have a nice day. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Dr. Prima Astuti Handayani, STMT, for the speech. Ladies and gentlemen, it is my pleasure to introduce the rector, which on this occasion was represented by the Vice Rector, The Excellency Professor Dr. Zainuri SAMSE AKT, to deliver speech, and afterward, we would like to request the Vice Rector to officially open the 10th Engineering International Conference.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning from Indonesia. First of all, I would like to express my gratitude to Allah SWT for blessing and mercy that we could meet in this 10th Engineering International Conference virtually. Next slide. On behalf of Universitas Negeri Semarang, allow me, Rektor Universitas Negeri Semarang, take great pleasure in welcoming you all speakers. The first, Associate Professor Eromoto Hiroshi, Professor Susun Liu, PhD, Associate Professor Junaidah Jai, and Professor Dr. Worodia Pitalengga, STMT. Senior Management of Universitas Negeri Semarang, and of course all presenters and participants in this 10th EIC. Next slide. Ladies and gentlemen, next slide. Let me introduce the vision of UNES to be a conservation insight university with international reputation. UNES has spirit as a house of knowledge. Here we always built our campus to develop civilization in producing quality of human resources in various fields in order to make better life. Next slide. I would like to bring your attention to our milestones, UNES, start from 2020 up to 2024. UNES is a teaching institute of higher education, or here commonly called LPTK. So we are having two principal aims: growing as a research university and teaching university. Next slide. UNES, a house of knowledge. We are growing and continuing to innovative in any sectors, including in developing research innovation. We can see here that the number of research publications is rising every year. Next. By having this 10 EIC, we do hope this corpus publication will increase. So I really appreciate to our committee and the Dean Faculty of Engineering who are having cooperation with IOP conference series in preparing the reputable output of this 10 EIC. Ladies and gentlemen, as a rector, I'm so happy this 10 EIC raised an update issue in this conference by having a good theme, exploring the innovation of green advanced research in applied sciences, engineering, and technologies. This theme was chosen to overshadow the field of applied science, engineering, and technology. Next slide. It is expected to be a green advanced research innovation center, mainly the concept and application of green technology. It is important for ensuring sustainability in the sectors of energy, material, building and construction, waste management, and transportation. That means Faculty of Engineering of UNES fully supports the vision of UNES in reaching international reputation. Again, thanks to all the committees. Next slide. Ladies and gentlemen, finally, it is expected this 10 EIC can produce significant and valuable ideas and also design the various possible contribution to the education system both in Indonesia and the world. I hope we can continuously build and develop collaboration with foreign institutions to improve human resources and bring out goodness to the world. With this remark, I declare this the 10th Engineering International Conference officially open and wish you all grateful deliberation. Thank you very much for your attention. Enjoy the 10 EIC. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much. Ladies and gentlemen, we arrive in photo session. So in this good occasion, let us to take a picture on a slide. Please turn on your camera and I will start from the first slide. From the first slide, 1, 2, 3. Thank you. And for the second slide, 1, 2, 3. Thank you. For the third slide, 1, 2, 3. Thank you. For the fourth slide, 1, 2, 3. Thank you. And for the fifth slide, 1, 2, 3. Thank you. And for all invited guests that have another agenda, may leave the Zoom room. Kami persilahkan kepada Bapak dan Ibu tamu undangan untuk dapat melanjutkan kegiatan. Kami mengucapkan terima kasih atas kehadiran Bapak dan Ibu sekalian.
Nuhun Pak WR1, Bapak Ibu pimpinan.
Finally, ladies and gentlemen, we get to the main agenda of this conference. There will be 4 presentations from our keynote speakers. The first session, there will be 1 keynote speakers. There are Dr. Enomoto Hiroshi from Faculty of Mechanical Engineering, Institute of Science and Engineering, Kanazawa University. With the moderator of this session is Muhammad Faisal Ardiansyah Arifin, STMT, PhD. Without further ado, the moderator, please move forward.
Good morning, Professor Enomoto. We hope we find you in healthy and good condition this morning. Thank you very much for your willingness to be our keynote speaker in International Conference IEC 2021. We are highly appreciative of your participation in this conference. It is an honor for us that Professor Enomoto can join in this conference. We believe your sharing knowledge in the conference will be a valuable experience for the audience. First of all, let me introduce the background of the curriculum vitae of the Professor Enomoto for the first session in this conference. For the first round of the first session in the conference. The complete name of Professor Enomoto is Hiroshi Enomoto. He has a PhD in engineering. He is an associate professor in Faculty of Mechanical Engineering, Institute of Science and Engineering, Research Center for Sustainable Energy Technology at Kanazawa University. His formal education, he did his Magister Engineering in Aeronautics and Astronautics at the University of Tokyo, Japan, at 1996, and he continued to take a PhD in the same field in Aeronautics and Astronautics at the University of Tokyo, Japan, and finished his study in 1998. His work experience in 1997 to 2001, he became a research fellowship for young scientists at Japan Society for the Promotion of Science. And then he continued also become assistant professor in Osaka Prefectural University, Osaka, Japan. And from 2001 and present to now, professor in Kanazawa University at Japan. He births in January 27, 1970 in Osaka, Japan. His achievement in his field, he has a Ministry Prize of Economic Trade and Industry in 2005. He also achieved International Federation of Automotive Engineering Society Award in 2005. He also have a Commendation for Science and Technology by the Minister of Education, Culture, Sport, and Science and Technology in 2007. And lastly, his achievement is a Young Research Encouragement Award, Confucian Society of Japan in 2007. For the first round of this session, Professor Hiroshi Enomoto, he will bring a topic about the hydrogen effect on the ignition timing of reciprocated engine for biosyn gas usage. We believe this title is very interesting for us to learn, to hear from his experience. And we just continue to the next sessions for the first round. Please may Professor Enomoto start the presentation. Thank you, Professor Enomoto.
Okay, thank you. Can you see my monitors?
Yes, I can see your monitor clearly, Professor.
Okay. Then thank you, Chairman, and thank you, the staff of EIC conference. This is Hiroshi Enomoto. And today I'm talking about the gasification system and the generating system with wood pellet. And in our laboratory, we developed the small gasifier for the reciprocated engines. And firstly, I want to introduce you the practical case in Europe. This is a photo of the hospital, and in Belgium, they have a large hospital. This is the capacity of the hospital. And in this hospital, they try to use the renewable energy for the electric power and heat. In this case, they use this capacity generator, and efficiency is almost 30%. And they drive this system almost through years. And this is the schematic of their system. The gasifier, I'm sorry. They developed the gasifier. The name is NOTAR, like this. And with this system, they drive the Yenbacher engines. The spec is like this. And with this system, they can use the wood pellet or wood chip from around the mountains. And as you know, in Europe, they have to develop such renewable energy. So the hospital can get some budget from the local government, so they can drive this system. However, as you know, the capacity, so 750 kilowatt, is not so small in Japan because our land is not so large. So we have to develop much smaller one. At the time, the small system, they should be operated with daily start and stop or weekly start and stop system. This means we have to mention about the stability of the system. As you know, at the start condition, the system is not so hot. So we have to maintain something, especially in Japan. In winter, it's very cold. So it is not easy to start smoothly. And the next problem is the mixed fuel usage. As you know, in Japan, the summer and winter, the temperature is not same, and the humidity is also not same. So the produced gas condition is not same. And we have to modify the fuel component for the request of power or heat. However, in Indonesia or in Semarang, the temperature is not so changed through year. So maybe this is a very special program for Japan or Europe. And we have another program. As you know, the renewable energy sources are not only from wood. We have PV, photovoltaic, or wind turbine, or hydropowers for the renewable energies. However, these sources are not stable. So we have to develop how to use the surplus of these renewable energy sources. And as you know, most researchers try to produce hydrogen from these surpluses. This means we have to mix up the hydrogen with another combustible gases. Then we have to consider about the combustion characteristics of hydrogen. And in summer, especially in summer, the composition of biogas, biogas means methane and carbon dioxide mixture or synthesized gas from the gas fire are not same in winter, especially the density is very different. As you know, the temperature is very, very hot in summer. So we have to mix up several combustible gases to the syngas from biomass. Okay. Then, firstly, I present you the engine performance with producer gas or biosyngas. And after that, today's subject, how to measure the tar component in the producer gas. Then for the engine performance, the quality of power is not only the kilowatt or something. In this case, we have to consider about covariance. If the engine has too much covariance, we cannot operate it clearly. And in this case, we mentioned about the IMEP. The indicated mean effective pressure. This is the same, almost same as a load of the engine. And normally, the COV IMEP depend on LHV. The LHV is low heating value of fuel. And the second is the combustible composition of ratio. So in this case, the hydrogen and the methane ratio is most important. And we use the city gas instead of the methane because we need so much methane to drive the engines. And the engine speed condition is like this. And IMEP is like this. And in this case, the air excess ratio is very important. If you have done knowledge on air excess ratio or stoichiometric conditions, I hope you to check them in internet now. And to consider these phenomena, we need several definitions. And we measure the cylinder pressure like this. I'm sorry. In the cylinder pressure measurement, the output is time history of pressure. The first plot is the cylinder pressure. And in reciprocated engine analysis, the time is the same of crank angle. So we use crank angle for time. And at crank angle 0 means top dead center. The top dead center means the piston position is the highest in the cylinder. And in gas engines, we have to define the ignition timing. And in this picture, the case of 30-degree BTDC is shown. The BTDC means before top dead center. So in this picture, 0 is top dead center position. So -30 is the ignition timing. And from the first plot, we can calculate heat release rate. Heat release rate is the second plot. Firstly, the heat release rate is almost 0. And after the top dead center, we can measure the maximum heat release rate. And in the operation, we have to design the position of heat release rate to achieve the highest efficiency. And to consider them, normally we have to think about the combustion ratio. The combustion ratio means how much fuel are combusted during the phenomenon. In this case, we define like this. And from these calculations, we can predict the cylinder pressure, like the fourth plot. In this case, the maximum temperature is almost 1,800 kelvins. Maybe not so high compared with normal liquid fuel engines. And this is a schematic of the gasification generators, very simple one. We use wood pellet. This is normal one. Maybe you can buy it in Indonesia or in the world. And firstly, we feed these pellets in the gasifier, and we sample the tar component like this. And after the cooling system or soot removing system, we clean up the synthesized gas or produced gas, and we mix up the methane or hydrogen, and we operate the reciprocating engines. So tau measurement point in this case is just after the gasifier. However, we measure a lot of points to evaluate the cleanup system. This is a photo of our gasifier, maybe very small. And we use very simple pipe, stainless pipes to build these equipment. And in our case, the capacity is almost 6 kilowatt. And the diameter of reactor is almost 127 millimeters. And this is a reciprocated engine. Maybe you can buy it for the in Japan, we use it in a golf course. This is an engine for golf cart. So with this engine, this is the typical result for the indicated thermal efficiency. With syngas, the efficiency is much little larger compared with city gas. And the maximum is almost 0.4. So 40% is changed from gas to power. And at this time, we have to think of MBT, the most advanced for the best torque. And in city gas case, 30 or 40 degree is MBT. And syngas case is 40. The difference is very large. So you have to be careful about the ignition timing. And today I will explain the reasons. The left plot is the ignition timing with 30 degree. And the right side is 40 degree. And you can find the difference of the stability. The larger COV IMEP means not stable, and the lower one is stable. This means the left side has not stable, and the right side has almost stable. As you know, the producer gas from gas fire is very low LHV gas. So around 4 megajoule per cubic meter is not so stable with 30-degree BTDC. On the other hand, 40 is stable. However, if you can use much larger LHV, the stability is very good compared with other cases. So, of course, we hope to mix the another fuels because the syngas from gas fire is not so high LHV. However, in this case, which fuel is better, hydrogen or methane? Of course, methane is better because it's very familiar for reciprocated agents. However, as I mentioned, from another renewable energies, the hydrogen is easier to be used. And we changed the ignition timing and measure the heat release rate peak position here. Oh, I'm sorry. Then you can find the HRR peak position is almost 0. This means the T top dead center, the stability is lowest. This means we have to design the ignition point that HR peak position is almost TDC. Then, if you use the hydrogen mixture, if you measure the peak position of heat release rate, it is not so hard to get the highest efficiency. This is another evidence of the best ignition timing. With hydrogen ratio, with larger hydrogen, with lower hydrogen ratio, the stability is not so good with 30 ignition timing. On the other hand, in the methane, also in the methane, you can find not so the difference because the methane ratio, we cannot achieve larger methane ratio. And this is analyzing of the combustion duration. With higher hydrogen ratio, the main combustion duration is lower compared with lower hydrogen ratio. This means higher hydrogen ratio makes a faster combustion. As you know, the hydrogen has a fast combustion phenomena. So in some case, it is better for higher efficiency. On the other hand, the methane doesn't show such high combustion duration. So maybe if you want to achieve higher efficiency, the hydrogen should be better. And this is a change of thermal efficiency. In this case, the 10% of hydrogen should be the largest. And the lower methane should be better to achieve the higher efficiency. So too much methane or too much hydrogen is not good if you want to achieve higher efficiency. And for the stability, we measure the change of seasons. As you know, in winter is January and in summer is July. In winter, the stability is better than summer because maybe the density is different. However, this is maybe just only for Japanese or European case. If Indonesian case, maybe you can achieve much easier conditions. So this is the operation of the reciprocated engines. The next one is how to measure the tau. This is a schematic of our present gas fire. I sent this PowerPoint to the staff of EIC. So if you want, please ask them. In the analyzing, you need GCMS. Maybe you know the mass spectroscopy with gas chromatograph. In this case, I mentioned you to use not only scan mode but also SIM mode. It is necessary. And the scan mode is just only for the heavy or middle tau component. Heavy means large molar weight. And for the quantification, the ECN, equivalent carbon number method, is useful. However, the accuracy is not so good. So it depends on you. What is your target? This is most important. And this is equipment. Dr. Risky tried to measure the tau in our laboratory. At that time, we used just only 3 bottles. However, after that, we check the details again. And now we use 5 bottles. This means you need almost 1,500 millimeter for the length of sampling tube. It is not so short. So we need much easier system, but maybe it is not easy. And another point is solvent. We use acetone. In some case, you use a kind of alcohol because of the boiling point. But if you want to check the benzene or acetic acid, the acetone is necessary. And at this time, the boiling point is important. So you have to check how to keep the lower temperature during the measurement or during the analysis. And another way to check the tau component, the GA, gravimetric analysis, is easier. As you know, you need a hot bath for the GA, but now you can get such small equipment very easily, and the price is also very small. So it is not so bad. However, at the time, the precision balance is necessary. It should be one of the problems. And this is today's conclusion. I'm sorry, I used too much time, so please read out it. Thank you very much.
Thank you very much, Professor Hiroshi Enomoto, for the interesting presentation about the hydrogen effect on the ignition timing of reciprocated engine for biosyn gas usage. Even this research based on the Japan condition, and Professor Enomoto said the winter condition is better than the summer condition, and actually in Indonesia we can achieve this condition easier than Japan. This interesting presentation, we sure it will be great advantage to develop the green energy in the future. Okay, we just continue to the next session for the question and answer session. For the first session, we will give the opportunity of audience to give a question. Actually, there is already one question from Dr. Rizky Fitrinaryanto. This question is in this research. In the gasification system will produce tar. What is dangerous effect if tar in combustion system, which is better for efficiency between syngas plus hydrogen or syngas plus city gas in the Japan condition, Professor Hiroshi Enomoto. You may write down first the question, or you can answer directly, Professor Hiroshi Enomoto. Which one is more convenient for you to answer first, or just write down first the question?
So for the first question,
yeah, maybe we can
dangerous
open the
effect.
chat.
So the most dangerous is the kind of fast combustion. So a kind of explosion or something. As you know, the pure hydrogen is very dangerous, as you know, because the flammability range is very high, very wide. So very few hydrogen could be combusted.
Only a few hydrogen very combusted. So
On the
this,
other,
this hydrogen is unstable. You mean?
Yeah, that's it.
Yeah,
and moreover, the size of hydrogen is very small, as you know.
Oh, the size of hydrogen is very small.
So you should be careful about transporting of hydrogen.
Okay.
So, so the usage of hydrogen, the risk is just only for hydrogen, not with producer loss.
Just only for hydrogen, not the
that's it. Yeah. And about the tar, now Dr. Naryanto, Dr. Rizky asked me about the tar effect.
Yeah, about the tar effect in combustion system.
In some case, the tar amount is not so much. So maybe not so much. So it is not so dangerous.
In some case, it's not so dangerous. You may explain to us the situation for the case, the undangerous case for the tar effect of the tar, Professor.
So yeah, and for the usage of syngas, the tar is not so dangerous, but the tar problem is just for the operation of the gasifier. As you know, the gasification system should be operated for a long time.
The gas operational system should be operated in the long time.
Yeah, not only for few hours, but few years or several decades.
Oh,
okay. Yeah, during such long time operation, the too much tar should be stop the system.
Such long period, so much tar should be stop the system of the computer.
So we have to measure, or we have to find how much tar makes such damage on the system.
Oh, we need to calculate how much tar can stop the system. So it's depend on the system working or the load capacity or something, Professor.
That's it. And moreover, the temperature or humidity is very important. As you know, and the humidity.
Temperature and humidity.
Yeah.
Temperature and humidity is very important. That will be influence the effect of the tar. Okay.
That's it. As you know, in Indonesia, the temperature is much higher than Japan.
Yeah.
Then maybe the tar trouble should be lower or smaller than Japan. Because the temperature is higher.
Because the temperature is higher, so the tar efficiency will be lower. Okay.
That's it. Because the tar maybe not be condensed because temperature
not
is
be
high.
condensed because the temperature is high, so the tar is
Yeah,
not be
that's it.
condensed. Yes, get it, Professor. Yeah, yes. We hope doctors can understand and accept the answer also.
Yeah.
Okay.
And yeah, okay. And with in the second question, okay?
Okay, the second question is okay.
What size is smallest upper size of the system? So as I told you, in our laboratory, the size or capacity is almost 2 kilowatt or 5 kilowatt, very small.
Just 2 kilowatt or 5 kilowatt.
Or 5 kilowatt, yeah, but this is too small compared with gas fire size.
Compared with the gas fire, it's too small. Okay.
So how to say? So the reciprocated engine is very small, like as your motorcycles. However, the gas fire size is much larger.
The gas fire size is much larger.
Yeah. So maybe 50 kilowatt or 30 kilowatt, maybe the smallest with a reasonable usage.
The reasonable usage about 50 kilowatts or 50. Okay.
Yeah. And of course, you can make the mobile one. You can make, however, maybe not so reasonable.
It's not reasonable. Why is not reasonable?
Reason is not affordable.
Not
So
affordable.
the price is not so good.
Oh, it's not economically. So
yeah, maybe.
Maybe to produce the syngas without any result, it's not
yeah.
It's not affordable. It's not efficiently in economic and financial way. Okay.
Maybe.
Maybe. So maybe we need to try, Professor. Maybe.
That's it. Yeah. And the second question. And you can drive it with just only syngas.
Yeah.
You can drive it. Especially in Indonesia, your temperature is high, so you can do it. However, the output power is not so good because the density is not so high.
Density is not so high, so the power is not so good.
That's it. So you can drive, but power is not so good because temperature is high.
So it's disadvantages. So because become big disadvantages. Because
efficiency is not so bad.
Okay.
So the next question,
we can move to the next question from Dr. Samsudin Anis. Yes.
The LHV of producer gas only for how far it can replace?
I would like to, Dr. Anis. He would like to ask about the tar problem. As we know, the tar is one of the big problem in biomass gasification. So how about engine performance when applied as a fuel?
So as you know, the methane LHV is almost 10 times of this producer gas. Okay, so this means the output power is not good, even though you use the same engines. Okay, so if you want to use a large power or a large capacity, you need larger engine, much larger engine compared with methane engine or something. So you can replace it very easily, but you need large engines to get the requested power.
Okay, so maybe Dr. Anis can respond to Professor Enomoto about his answer.
Okay, thank you, Dr. Faisal. Good morning, Prof. Enomoto.
Mhm.
I'm Samsudin Anis from Universitas Negeri Semarang.
Mhm.
I would like to ask about the tar problem.
Mhm.
As we know that the tar is the biggest problem in biomass gasification, I think.
That's it. Yeah.
How about it's affect the engine performance, or how about the engine performance with if we apply the syngas or the producer gas into the engine? For example, maybe in short time or the long time period like that. Thank you. Please explain. And the second question is about water. In gasification, we can use to evaluate the performance of the gasifier as in the presentation you saw in the presentation. I would like to, could you please to explain more about the statement? Thank you, Prof. Enomoto.
For the first program, the TAR program is very important, but in our understanding, the water in the syngas should be important to solve the problem. Maybe you know the problem in the cleanup system. Okay, to clean up the tar from the syngas, we have to maintain the cleanup system. As you know, at the time, the water ratio in the drain is very high. So if we can reduce the water ratio in the gas, maybe we can drive the system much longer with a simple maintenance, maybe. And this means, how to say, the condensed water program. Okay, then in Indonesia, you have higher temperature compared with Japan or Europe. This means your how to say, your environment can keep the gaseous water with high density. How to say? Can you understand?
The humid air is high.
Yeah, higher compared with lower temperature cases like Japan or like Europe. Then your cleanup system should be operated with much longer than Japanese case, maybe.
So the water, it means will affect the tar production on time in the producer gas like that.
No, not on tar production. Maybe the water doesn't have such efficiency on tar production, but tar removing or tar cleaning in in tar removing or in tar cleaning, the water role is very important.
So we have to remove the tar and water in producer gas, right?
That's it.
Thank you.
Okay. Okay. Thank you very much, Dr. Anis, for the discussion with Professor Enomoto about the question. And may we have one more question, Professor Enomoto? There is still one question from Dr. Suhartono from Universitas Jenderal Ahmad Yani. He asking about the LHV of producer gas only 4 to 5 mg per meter cubic. How far it can replace the fuel in gas IC engine?
So no, it's easy. With 4 megajoule per cubic meter, it is not so hard, or it's very easy to replace it. So you can replace the fuel now if you want. However, the power is not good, maybe, or power is not enough for your request because the heating value is very low. compared with normal fuel gas.
Okay. Okay.
Hmm.
The power is not so good, you mean? So
That's it. That's it.
Yeah.
That is a problem to usage of syngas for generator.
Oh, okay.
Hmm.
Okay. Okay.
Hmm.
Actually, we still have 15 minutes, Professor.
really?
Enomoto.
I'm sorry.
May we still open another session of question and answer, Professor Enomoto? You willing to answer more question maybe for the audience, from the audience? I will try to open one or two more questions if some audience still wants to asking it, because we still have 15 minutes. Okay, for the audience, we still open the question and answer session. Okay. Okay, if there is no question from the audience, Professor Enomoto, once again, thank you very much for your sharing knowledge with us, for your interesting presentation. We hope the topic will encourage us to develop the green energy in the future for the better generation, Professor Enomoto.
Okay, thank you.
Okay. Once again, thank you very much. We hope I can see you in the future. I can meet you directly in Japan, maybe.
Yeah, maybe.
Maybe.
You're welcome.
Yeah. Okay. Okay. Thank you very much, Professor Enomoto.
Thank you.
So, thank you.
Thank you for the audience.
Thank you for the audience. Okay. Okay. Because we still have 10 minutes to the next. Actually, we still waiting for Professor Liu to join with the conference. He's still on the process to join because. Okay. Oh, sorry. Okay. Okay. So the next session after the question and answer, we will give a e-certificate to Professor Hiroshi Enomoto to appreciate his participation as a keynote speaker in the Engineering Internal Conference 2021. Okay. Thank you.
Thank you. Then there will be a virtual certificate submission by the Dean of Engineering faculty from the first keynote speakers, Dr. Enomoto Hiroshi.
Okay, thank you.
Thank you very much.
Thank you very much, Prof. Okay. Okay, as a token of appreciation, we would give a certificate to Associate Professor Dr. Enomoto Hiroshi from Faculty of Mechanical Engineering, Institute of Science and Engineering, Kamizawa University. Thank you for insightful presentation. Thank you.
Okay, thank you very much, Dean.
Thank you. And for the second keynote speakers, Professor Xiuxun Liu, PhD, from National Yunlin University of Science and Technology. With the moderator is Muhammad Faisal Ardiansyah Arifin, STMT, PhD. To moderator, please move forward.
Okay. I would like to give the information. We are so sorry. Right now, we still waiting for Professor Susun Liu to join, because right now he has a emergency situation about his mother. His mother is still in the critical condition in the hospital, and I still try to contact him to join with us. The latest information from Professor Susun Liu, he still want to join with us, even only for a few minutes. Maybe the audience can waiting for about 10 minutes. He will join at the on time about 9:30 Indonesian time. Okay, thank you very much.
Akan ada masa di mana kita menjalin rasa manusia dengan semesta. Mendaki ke puncak tertinggi, menggapai tujuan dengan kerja keras dan strategi. Perjalanan mengajarkan banyak arti dalam setiap langkah yang terlewati. Bercerita lewat asa untuk terus dijaga.
Manusia sejatinya berencana, menata cita-cita dalam bingkai rencana. Percaya bahwa keindahan tercipta bukan instan, melainkan lewat prinsip dan pedoman. Kreativitas dan imajinasi saling berkolaborasi, mengasah naluri, menjamah potensi. Tak akan bertemu ujung untuk apa yang kami kejar. Tak akan tercipta rasa tanpa belajar. Apa yang kami lakukan berawal dari sebuah ilmu yang kami emban di rumah peradaban, Universitas Negeri Semarang.
Kemajuan kita sebagai bangsa tidak bisa lebih cepat daripada kemajuan kita dalam pendidikan. Pikiran dan wawasan menjadi sumber daya fundamental.
Di sini saya belajar banyak hal, seperti mempertajam kecerdasan, memperkukuh kemauan, dan memperhalus perasaan.
Pendidikan adalah senjata paling ampuh untuk mengubah dunia, termasuk Indonesia. Berangkat dari mana? Dari diri kita sendiri.
Inilah rumah ilmu pengembang peradaban, tempat tunas penuh talenta tumbuh bermekaran. dalam kasih sepenuh hati, bertumbuh menemu arti. UNES Gemilang untuk Indonesia Maju.
Kegemilangan memandu UNES dalam melahirkan generasi berkarakter dan berprestasi, agar tunas muda Indonesia bertumbuh, menemukan peran dan makna demi kejayaan Indonesia dalam peradaban dunia.
Setia mengawal semangat perubahan demi kemajuan bangsa dan peradaban. Sebab kami percaya niat baik saja tak cukup. Denyut inovasi harus terus berdegup. Arom luhuring pawiyatan ing astoniro. Semangat ini berdiam di hati, terpatri di jiwa kami.
Selamat datang di Universitas Negeri Semarang.
Gemilang untuk Indonesia Maju.
Selamat datang di Universitas Negeri Semarang. Gemilang untuk Indonesia Maju.
Akan ada masa di mana kita menjalin rasa
So Faisal, yeah, can you hear me?
dengan semesta.
Hello.
Yes, hello, Professor Liu. Yes, thank you for joining with us, Professor Liu. Thank you for deserving
So is my sound clear?
Yes, your sound is clear, loud and clear.
Because
Professor.
I have no idea the Wi-Fi is okay or not.
It's okay, Professor. Your sound is loud and clear, and your picture also clear, is not?
Okay.
Yeah, we can see. Okay. Okay. For the audience of Engineering International Conference 2021, so we can continue. Professor Susun Liu already joined with us right now. Thank you very much, Professor Liu, for your willingness to be our keynote speaker in the Engineering International Conference 2021. It is an honor for us that you can join with this conference. We are highly appreciative of your participation in the conference. We believe your knowledge, sharing your knowledge in this conference will be a valuable experience for the audience. First of all, let me introduce the Professor Susun Liu background and his curriculum vitae. Dr. Susun Liu received his bachelor degree in civil engineering from National Taiwan University, Taiwan. And he continued to take the structural engineering to take a master in Stanford University, USA. And he continued to took his PhD degree in construction management from Purdue University, USA. Right now, he is currently associate professor in Department of Civil and Construction Engineering at National Union University of Science and Technology, Taiwan. Right now, he also become a director of Smart Construction Management Consulting Center at the National Union University of Science and Technology. His prior academic career, Dr. Liu worked as both in construction industry and IT industry. As construction engineer at Taiwan Formosa Group, and from IT industry, he working in the analysis at Oracle Corp USA. Since 2014, Dr. Liu served as advisory consultant and provided customized construction IT service to several construction firms in Taiwan. Right now, his research interests include construction IT technology, project scheduling optimization application to construction management. Till present, he has published over 70 articles in high-quality journals and conferences. He continues published in leading SCI or SSCI journal include Automation in Construction, Journal of Construction Engineering and Management in SSCE, Applied Science and Sustainability in MDPI. Today, Professor Sun Liu will bring a topic about the preventive maintenance model for national school buildings in Indonesia, using a constraint programming approach as an optimization approach to develop the preventive maintenance model. We hope this topic will be interesting and encourage us to give a sustainable green building in the future. Professor Liu, you may start your presentation. Thank you very much.
Okay. Okay, thank you, Fazar. And I at first, I think I must give my apologies to all of you because I couldn't attend the opening ceremony this morning because I have some family emergencies. So I also didn't get sleep last night. Okay, so if you feel my logic is kind of fuzzy, please forgive me. Okay.
Okay, it's okay, Professor.
Okay,
actually,
so
we still already feeling happy.
Yeah, I'm sorry. I'm sorry. Yeah, I could not attend. So and also I also ask for your pardons for me to, after my presentation, I need to leave. Okay, go back to the hospital. Okay. So I will try to stay focused on today's presentations. So may I share my screen?
Yes, you may share your screen, Professor.
Okay. So the slides is good.
Yeah, the slide is clear, Professor.
Okay. Okay. So let me hold on a second. Okay. 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 So good morning, everyone, and dear professor and dear scholar and students in Indonesia and all around the world. Today, I would like to share my latest research regarding the optimizations model for building maintenance problems, applying CP. We call it constraint programming. So actually, this research is done by today's session organizer, the Fazar, and so I think I will just share our conceptual concept regarding how do we approach this problem. We try to solve the building maintenance problem. Okay. So today's presentations, I will give you a brief introductions to the building maintenance problem, and I will present our approach to the solution of this kind of problem, and also I will show you our finding through the case studies, and I will give you our observation from our result. Then I will give the general and specific conclusions at the end. Okay, so I think all of you probably might interesting about what's the building maintenance problem, and how can we make a good definitions on building maintenance problem. So for a building, we all know that as time goes by, the building service and energy performance is getting worse. So definitely we need from managers' points of view, we need to make a good maintenance plan, right? So before we define what's building maintenance problems, I think we should go into to examine several factors. For example, we have the we need to define what's the building deterioration rate, right? This is the first. Then we also need to make a good make some assessment on the building current condition, and also we need to categorize the building usage. Okay, but for the testing cases, this time we are using the public school, like the elementary school, junior high, and high school, and senior high in Indonesia. So this is our test data. So the building usage is mainly for education purpose. Okay, and also about the building characteristics, right? We all know that we have a different building types. Okay, the traditional is using the reinforcement concrete. We call it RC structures, right? And we also have some wooden, right? Especially the not in Taiwan, but I know that some the East Western country, they are using the wooden structures. So, but in here, I think in our case study, we are using the RC structures. So at first, we are facing the challenge to make a good category of the building characteristics. So in this kind of the problem solving, then we propose an optimization approach to this problem. Okay, so let's go on to the next slide. So we all know that the preventive maintenance strategy serves the purpose to ensure the building service performance and building safety condition. However, we need to consider two steps. The first is we need to make a good definition regarding the building deterioration rate, or in terms of equation. Okay, in order to forecast the building future condition, right? So based on several previous research, and also we all know that we need money to maintain, right? So every year for all governments agencies, they all get inefficient maintenance objects for all buildings that need to be repaired. So that means we need to trade off, right? We need to do some trade-off decisions because we don't have enough money. So that's the challenge to this problem, the building maintenance problem. We need to make a definitions regarding the deterioration rate, and also we need to plan our maintenance budget first. Okay. So regarding the roadmap of a maintenance strategy development, the first, okay, we need to make a decision regarding, okay, what's our maintenance strategy? Okay, the traditional way to building maintenance is we always use the reactive strategy, right? So what's reactive strategy? Usually the maintenance or the rework is wait for probably some structural components damage. Okay, we found the problem, then we fix it. So this is we call reactive strategies. So that's typical for most government agencies are using currently. So in here we propose the preventing strategy. That means we try to forecast, just like I say, we based on our assessment on the building current status, we we give the index score. Then we based on that. Then in this research we call it BCI, the Building Condition Index. So based on the BCI value, then we do our preventing maintenance actions. So in here, right? So once we make sure we want to do the maintenance action based on forecasting, based on preventions, then we develop our approach to find the optimal maintenance plan, or we can call it the maintenance schedule. So we using the optimization approach. Okay. Sometimes the maintenance actions usually is based on experience. So it's a experience or oriented. So in here we try to make it in more scientific way. So we using optimization approach. So we develop optimizations model. Then okay, we using two different models to tackle maintenance problem. Okay, so we using this, and it's based on the result we can give our maintenance suggestion. Okay, so in this research, our objective first is that we try to classify the Indonesia public school building conditions based on the definition of the BCI. And the second is that we examine two types of deterioration rates with different characteristics. Based on the linear equation, which is done by most government agencies, including Indonesia's government. The other is the Professor Gursiv's work. We are using his nonlinear deterioration rate as the model parameters. Then we try to provide an optimization approach to select the proper maintenance schedules in a timely manner by considering the annual available maintenance budgets. Okay. But definitely our management goal is try to preserve all buildings in you can say it's we can say it's a decent condition, but however, because sometimes our resources are limited, so usually we try to make all maintenance buildings in a lowest acceptable condition. Okay, so. And also, the interesting part about this research is that we use a new idea. We adapting the resource constraint project scheduling problems framework into the building maintenance problem. So we try to provide a new aspect for this problem. Okay. Okay, so let's see regarding the problem solving steps for building maintenance problem. So at first, for any personnel or managers at building agencies, they are facing the problem. They are facing the factors they need to consider first before they try to solve this problem, right? So they need to evaluate the time service, the lifetime target, the time frame target, and also he need to evaluate to see if under his responsibility area, how many different types of building and how many units, and also for each year, the government fund is always limited. Okay, so but this is a this is need to be evaluated annually, right? Per each year. Okay, then regarding the deterioration factors, okay, so we all know that that will depend on the usage, okay, the usage type, and also that will depend on the local weather condition, and also that will we also need to consider the agent factor, right? And also if the power maintenance is not good, then okay, this is also a factor will impact the BCI value. Then okay, so we get the BCI value here. Then we try to use the good maintenance strategies. Okay, so in this research we are using optimization approach. So we will have our optimization models, which is built based on constraint programming, and we implement the different deterioration model, and also come with the BCIS. And also we define different types of maintenance treatment. So from the repair to renovation, and the last is reconstruction. Okay. So hopefully this diagram show the clear structure of how do we try to tackle maintenance problem. Okay, so let's give a brief introductions description regarding the CP, or constraint programming. So the constraint programming is a computer application that combines the AI and operations research technique for solving a specific CSP. We call this constraint set specifications problems, and also based on lots of research finding, is the CP is already proved it has a pretty good performance on combinational problems. Okay, so the first step of we try to develop the CP algorithm in this study is by defining the problems, but a specification on building maintenance problems that consists of several objective functions. Okay, in here we try to in this research we propose two models. Okay, our model ones, the OBJ, is try to minimize the total maintenance cost in order to fulfill the desired time frame requirement. Okay, so that's for our first model, and for our model two, we try to under the budget limitations, the annual budget limitations, we try to maximize the overall service time, the overall life cycle. Okay, so that's two different management goals. So we implement into two different objective functions. Okay, so we will talk about the detail later. So regarding the basic concept of the model, you can see that we define before we try to solve this problem. At first, we need to make a good definition on building factors, on building conditions. So in here, we're using the BCI, and we also define our deterioration equations, and also we define the maintenance treatment type. Okay, so you can see that we in model one we have four types. Okay, from 1, 2, 3, 4 represent the BCI improvement after treatment. So for the one is the little improvement. For type 4 is the great improvement. You can see that. type 4 is from fair. You can okay from very poor to good. Okay, for type 1, it's only just one little improvement. So show on the figure, you can see that okay, once the service level is going down as time goes by, and when the maintenance action is made, the BCI value is jump up. Okay, so just this. So our business process, our research process for Model 1 basically can divide into 2 stages. The first stage is that we need to get our data, so we call it a data preparation stage. So you can see that we need to make out the classification rule regarding the maintenance treatment, regarding the BCI conditions, and also we need to define the deterioration rate. Okay, so once we have our physical assessments here, then we can get the actual data for the input for the input of the optimization model. So we have the value, okay, the CIK, and also the yearly maintenance budget, and also our current initial building index, and RIS is regarding the deterioration rate. Okay, so low rate to extreme rate. So for the optimizations, so once all data, all parameters are set up, then we go to the model. Okay, so for Model 1, we try to minimize maintenance costs to fulfill the service time. Okay, so the decision variable here is simple, only 2: the BCI condition before maintenance and the condition after maintenance. Several constraints here. We have annual project constraint. We have the minimum, the BCI value. So in terms of acceptable conditions. Okay. Definitely, we also implement the 2 deterioration deterioration rate here. One is linear and the other is non-linear, and then we got our solutions. Okay, so that's the whole process of Model 1. Okay, so for the Model 2, the reason is why is that because we didn't consider the schedule concept in Model 1. So in Model 2, we try to make it like a project scheduling problem. We try to implement the project concept into the building maintenance problem. I think probably this is the totally new application to do that. So I think that most of you should be pretty familiar with the Gantt chart, right? The bar chart. So when we see the bar chart, that means we treat the maintenance activity as project activities. All the buildings, all the maintenance treatment, we represent it in like a single activity. So the yellow point is the initial condition. So in here we have 2 maintenance treatment here, compared with 4 maintenance treatment on Model 1. Okay. So this is we try to implement in RCPSP framework. Okay, so for the process, for the Model 2 process, is the same. We need to get the data, right? But this time we also need to classify the building calculation and also the building type. But in here we are using 3 types. Okay, 3 types here. Okay. Yeah. Actually, the 2 types is the active type. This is the passive activity. Okay. The type 3 is we define until end of a building to unserviceable, to broken. Okay, so that's a total different concept compared with model 1. Okay, so in here, when all our data is set up, we put into the articulation model. But because just like I explained, our model for model 2 is based on RCPSP framework. So our OBJ is different. So that in here, the objective function is we try to maximize the overall building service life. So the decision variable is compared with model 1 is quite complicated. So we need to define the different duration options for each maintenance option, and also we need to define the associated cost options. So you can see that the variable here is much more complicated compared with model 1. So also we have for the constraint is identical, okay? Because it's the same problem. We just try to use a different approach or different thinking to solve this problem. Okay. And also we need to define the start time for individual maintenance type or finish time for individual maintenance type. So we got our result. Okay, so then we expand the result here. Okay, so just like I said, in model 1 we focus on to discuss a different. We try to observe how different deterioration rate model can affect our result. So in here we introduce 2 deterioration rates. The one is linear, the other is nonlinear. So you can see that this is the scenario 1. So scenario 1 is we use the linear deterioration rate based on the government. Okay, based on the government. So you can see that on the different rates, the low rate, medium rate, and high rate and extreme rate. So you can see the change, the value condition before and the value condition after. Those are the selected. These are selected building. The total we are using 41 building. I'm sorry, I forgot to mention. Okay, so you can see that this is the sample of the result. Okay, for scenario 1, linear rate. So you can see that this is the result for nonlinear rate based on Professor Agusi's research. Okay, you can see the result. The result for same building is quite different. Okay. Okay. So I think we can make a small conclusion here. For the model 1, when we try to compare nonlinear deterioration rate in scenario 2, but the scenario 1 with the linear deterioration rate seems to be cheaper and less numbers of actions due to the slow characteristic of the rate. But you can see that this is unreal. So we ask for the nonlinear rate because it fits in the real situations. Okay, so this is the model 1, and for the model 2, okay, the time is close. So I try to finish as soon as possible. Okay, so we use 3 maintenance type, and 2 scenarios that we try to put focus on. For some buildings, they have the highest priorities. So we want to see how the model behave. So you can see that this is the result that we do not consider priority. So you can see, okay, almost 41 of them seems the same. Okay. And for this bar chart, you can see that because we put the first 4 buildings as priority building, so you can see that. Okay, this is we got a longer durations for better performance, especially for priority buildings. Okay. we can also observe the result. In here, more A represent a longer duration. Okay, a longer service duration. So you can see that. For here is for building 1 is 68. If we consider building 1 is the important building, then you can see that the duration service life increased from 68 to 77. Okay. Okay, so let's make a conclusion. Today's conclusion. So this study shows that the building deterioration rate is a certain factor that can shorten the building life cycle service and rebuilding on service of performance and efficient energy performance. So for model ones, we observe the nonlinear deterioration rate is fixing the real world example. And for we are using the 2 models try to solve this problem, right? So the model 1 focus on utilize the different deterioration rate, and the model 2 focus on we try to find a relationship between the maintenance type and the maintenance budget. Okay. And the final conclusion is that if although we use the 2 totally different recommendations thinking to try to tackle this problem, but from the result, both of the models' results shows a similar performance. Okay, try to preserve the building conditions. Okay. Okay, so I think that's all for today's presentation, and thank you for your listening.
Okay, thank you very much, Professor Liu, for the interesting presentation that building maintenance strategy in order to preserve the building serviceability and increase the building energy service performance. We are sure the interesting topic will give us valuable knowledge to develop the green building in the future, Professor. You may do the question and answer part, or just skip this, Professor, based on regarding the situation, Professor.
Yeah, no problem. Okay, I can answer a few questions. No problem.
Oh, okay. Okay. If that's so, we'll continue to the question and answer part. We open the 3 questions for the audience. Please, you may send the question using the chat. You may write down the question for the keynote speaker in the chat box. We open for the 3 questions.
Before answering your question, I wish all of you can stay healthy and hold on until this COVID pandemic has away. Okay.
Okay.
I really hope.
Hey, we hope you so, Professor. You and your family will hope
yes,
in good condition, healthy until the COVID-19 pandemic is end. Yes, because the situation in Indonesia is not so good compared to Taiwan, actually.
Yes.
So that's I still wearing masks. Sorry. Okay, the participant, we still open the question and answer session. Maybe have some question regarding with the maintenance strategy or optimization or scheduling. If there is no question from the audience, maybe between these two approach, Professor, to these two models, yeah. I just started first before the audience give the question. From the two different model or two different approach in solving the building maintenance problem.
Yes.
Actually, both of them is based on the preventive maintenance strategy.
Yes.
What do you think between both of this model is more reasonable in the future to apply, Professor? Deterioration model or using the scheduling model, the RCP-SP concept?
I think the scheduling models can give the building maintenance problem more flexibility. We can implement more practical constraints into scheduling model, right? What if? Yeah. What if we have another scenario? Building A and building B has some kind of a logical relationship for maintenance. That's possible, right?
Yeah.
Probably due to the area restrictions. Probably due to the maintenance materials. Okay, they are using the same material. Or same maintenance options. So once we fix building A, then the building B is also wait for fix. So for this kind of constraints, I think it's better to put it in scheduling model in RCP-SP framework. So I think the model 2 should be better for model 1 to address some practical considerations in maintenance problem.
It's better to address some practical
yes,
problem.
Yeah. It's easier, or we should say it's easier. It's easier for us in terms of a model development, right? We can just insert the constraints into the model and try to if we see all maintenance options as activities. So activity, we have start time, we have finish time. So it's easy for us to make a good schedule. If maintenance problems involve with the time, right? With the time selections, right? When these maintenance options need to be started, when need to be when this maintenance need to be finished. Sometimes we have this kind of a management concern, right?
Yeah.
The due date,
yes.
right? We have the due date concern. So if we have due date, then okay, we can have a. So I see Agung raising his hand.
Oh yeah. Yeah. Okay.
Hello,
okay.
Agung.
Good morning, Professor.
Yes, good morning.
Yeah, thank you very much.
Mr. Agung can if have any question to Professor.
Yeah. Agung is an expert on scheduling. Yes, go ahead.
No, Professor. Yes, thank you very much, Professor, for your time today, and I hope.
Yeah, no problem. I already tried to give my apology to the professors. Yeah, all professors. I'm sorry.
Yes. I hope you and your family will always be in good health. Yeah.
Yeah. It's hard to say. Yeah. Just when people get old. Yeah. Okay.
Yes.
Okay, please.
Yes. I see that this kind of model can be applied to not only to building, Professor.
Yes.
Maybe into a road network, something like that.
Yes, yes. Also the bridge, also the payment, right?
Yes. Is there any possible additional constraint or some modification needed to apply to other kind of building, Professor?
I think for the research, for this research, I think we didn't consider the rescheduling possibility here. So I think that this can be future work. We can try to implement the rescheduling the concept into the model 2, and try to simulate the real budget situation, right? Because in here we are using the forecasting, right?
Yes,
we forecast a plan. We focus a plan, but we don't know if the time comes, the budget will still be awarded enough amount.
So rescheduling,
because we always facing inefficient budgets problem.
So rescheduling model is also can be, I mean, can be the future work of this model, Professor.
Yes.
Yes. Thank you, Professor.
Okay.
Yeah. One more question, Professor, from Dr. Rizky Fitri Naryanto. He asking about, could you explain how to maintain the building in Indonesia better? As we know that Indonesia have two seasons, it's different with Taiwan.
Yes. So can you briefly explain to me how's two different reasons compare with Taiwan?
The two seasons in Indonesia, we have dry season and rainy season, Professor. In the dry season, the weather will be more hotter than and no rain, and will be more hotter than the rainy season. And during the rainy season, the condition will be like the hot season in the Taiwan. Will be many rain like storm. We like a typhoon. Sometimes we have a small typhoon in Indonesia in the rainy season. Often a small typhoon with a heavy rain. Yeah. So commonly we have no winter, so in here no snow, and the condition will be the challenge is about the rain, about the water.
Yeah, but I think in terms of a model perspective, right? So we all know that the different area have their different building characteristic, right? Like in Taiwan, we got more earthquake, we got more typhoon, right? Yeah. So for this kind of special conditions, so that's why I said the scheduling model has better flexibility to fit in the different to fit in the different real consideration. Just like I say, okay, you have a long raining season, right?
Yeah.
Yes.
Yeah.
Then just put this special concern into the model formulations as parameters, right? So that means the raining parameters in Taiwan should be totally different compared with the raining parameters in Indonesia. We still need to use the local assessment, but once we can make sure the local assessment is correct, it's okay, then just put it in the model. So that's the reason why we want to do a model. We try to solve the similar type of problems using the same model setup, right? But we need to use the different parameters. The variable is the same, just the parameter is different. So that's why we want to use, we try to develop a model. So this model can solve any general type of this kind of a problem, the building maintenance problem. Just we need a different assessment on parameter due to different local area.
Okay, Professor Liu, I want to know about the specific building in Taiwan. I'm sorry, I not yet go to Taiwan, but I ever live in Japan for 4 years. So yes. It's mean almost all the building in Taiwan is same in Japan. It's mean they in Japan they have so many earthquakes. It's different with Indonesia. Indonesia no earthquake, almost yeah, sometimes earthquake, sometimes not. So what is your suggestion for the building in Indonesia? And what is different between building in Indonesia and in Taiwan? Is mean more strongly in Taiwan than Indonesia to attack the earthquake like that?
I think it's not an issue to consider the difference between different areas. Just like I said, we built a model already, right? So this model can be applied on the same type of the same type of building maintenance problems. So just the matter of the parameter collections. Just like I say, okay, if we feel okay, according to the design criteria in Taiwan, probably for the design standards in Taiwan is different than the design standard in Indonesia. For us, it doesn't matter because we are the model builder, okay? But for the local professional, the local professional need to give us their assessment on their parameters, right? Because I live in Taiwan, definitely I'm not familiar with the situation in Indonesia. So if we want to do a cooperate research, so I need the input from Indonesia professor.
Okay.
Yeah.
Okay. Thank you very much,
yes.
Professor Lee.
Yes.
Yeah. The latest question from Dr. Hendrik. He asking about is there a maintenance program that specifically handles corrosion problems in buildings, Professor?
Actually, we do not consider corrosional problems specifically in this research. We're just treating as a model parameters. Just give me the parameters. You think, like, okay, you think there should be a specific deterioration rate for Indonesia local corrosion problem. Then okay, we need to make these equations correct. But actually, it required the field experiment, right? Sometimes I think this kind of data need to be gathered from the field.
Yeah. Okay. Thank you for the answer, Professor.
Yes.
And still one more actually from Dr. Rini, Professor.
Yes. Hello, Dr. Rini.
Hello.
Nice to see you.
Hello.
Hello.
Yes. How are you? Hello, can you hear me?
Yes.
Yeah, okay.
Yes. You may give the question, Dr. Rini.
Yeah. Thank you, Mr. Faisal, for the occasion for I can give a question for Prof. Liu. Actually, your presentation is very interesting because it also asked me to maybe I would like to know because my expertise is about natural disaster, you know, about earthquake, landslide, and now I'm
yes.
Earthquake. Maybe I give a little clarification for Mr. Rizky. Actually, Indonesia is also a huge country with earthquake possibilities, as some like Japan and Taiwan. And now our government is also issued about the policy about how to build the building and other infrastructure based with seismic code in Indonesia, because every day earthquake is always appear in Indonesia. That's why I think it's very important. But from presentation of Prof. Leo, actually your optimization is for the long period, right? But
yes, life cycle. Yeah, life cycle.
But actually, the earthquake we cannot predict about the earthquake or maybe other natural disaster. And how if the evidence about the natural disaster in the middle of the project of optimization, what should I do? Yeah, maybe I think it's a very good research. Could be linked between my expertise and Faisal or Agum expertise, because natural disaster is Indonesia is a very type of a natural disaster, not just only earthquake, but only landslide and other flood, and sometimes it could be interrupt our project in the field. That's my question, Prof. Thank you.
Yes. So okay. So I think probably this questions the Agung can answer it for me, because he's the expert of scheduling. Right? Yes. So is Agung there?
It's not there.
Yeah.
I think
Okay.
it's not here again, Robert.
Yes. Okay. So thanks for Dr. Rini's questions about your concern. Just like, okay, so you are saying when we already make up a maintenance plan, right? So what if is emergency risk happen? Just like you said, a big earthquake, right? Probably some kind of a disaster, right? So that means in terms of management, so we need to develop a rescheduling mechanism to adjust the maintenance plan, just like you said, okay? Because the new accidents happen, so it will change each building's current status. So at first, we need to go to the site to evaluate the current status for each building, right? To see the damage. Then once we get in terms of BCI value, after we make assessment, then we will get our new BCI value. So once we get the new BCI value, so we should ask for the central government for repairing fund, right? So we can use this model to do the rescheduling according to government's new policy or new funds to take into the emergency. Yeah. So I think that's my answer. In terms of a model, I think it doesn't matter for us. As long as we have the latest information input, then we can reschedule. Okay.
Yeah. Okay. Yes. Thank you, Professor Liu.
Yes.
We hope Dr. Rini is satisfied with the answer.
Yes.
Okay. We close the question and answer session, and we continue to enter the certificate, Professor Liu. Our Dean, Dr. Nur Kudus, will give a certificate of this conference to you.
Okay.
Okay.
Okay. So for all of you, yeah, I need to leave right now. So
no need, okay. Professor. No need.
Okay.
Just stay.
Okay.
Just stay.
Okay.
Just stay
I hope sometime I can go to visit you, and sometime if you come to Taiwan, please let me know. Okay.
Hey,
okay,
don't leave it. Don't leave it, Professor.
Okay.
Don't leave it first.
Okay.
I will give the time to the MC first to give the certificate. Okay. Thank you.
Okay.
Wait a minute. Okay.
Okay.
Thank you. That was a great presentation from our keynote speakers. Next, there will be a virtual certificate submission by the Dean of Engineering faculty for the second keynote speakers, Professor Xu-Xun Liu, PhD.
Thank you very much for your presentation, Prof. Xu-Xun Liu. from
Yes.
National Union University of Science and Technology Taiwan.
Yes.
This certificate as a token of appreciation. Thank
Okay.
you very much.
Okay. Thank you. Thank you very much. Okay.
Okay, thank you very much, Professor Liu, for your presentation today and join with us. And we are very grateful that you still can join with us today.
Okay. Okay. Thank you.
See you next
Okay.
time,
Okay.
Professor Liu.
Okay.
Bye bye.
See you. Bye bye. Bye bye.
Okay.
Bye.
Thank you. Ladies and gentlemen, let's continue to the next session presentation. For the second session, I would like to invite our keynote speakers, Dr. Junaida Jai from Faculty of Chemical Engineering, University Technology Mara, and Professor Dr. Waradiah Pitaringga STMT from Department of Chemical Engineering, Faculty of Engineering, Universitas Negeri Semarang. I would also invite Dr. Widi Astuti STMT as a moderator. Without further ado, the moderator please.
Good morning, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. It's my pleasure to be a moderator for this second plenary session. I'm Widi Astuti, and I would like to extend a very warm welcome to all of you in this session. First of all, let us thank God who have given us mercy and blessings so we can attend to this event without any obstacles. In this session, we shall have two prominent speakers. I'm glad to welcome Associate Professor Dr. Junaida Jai as our first presenter and Professor Dr. Waradiah Pitaringga as our second one. Before we begin, I have few housekeeping notes. Firstly, each speaker has 30 minutes presentation. Secondly, at the end of this term, we will have Q&A session. If you have any questions, kindly drop your question in the chat box. Thirdly, we will choose only 3 questions. So if you have further questions, you can connect directly with the speaker one-on-one through private message, or you can contact the committees. Now, allow me to introduce our prominent speakers. The first speaker is Dr. Junaida Jai. She is an associate professor in the School of Chemical Engineering, College of Engineering, University Technology Mara, Malaysia. Dr. Junaida received her bachelor's degree from Universitas Kebangsaan Malaysia, while her master and doctorate degree were obtained from University Technology Mara, Malaysia. Her researches focus on corrosion inhibitor, metal composites, synthesis of nanoparticle by green method, and encapsulation of essential oils. She published more than 30 papers in journals, more than 30 papers in proceedings, one book chapter, and 2 patents. She also received 6 awards, including Mitsui Chemical Award. On this occasion, Dr. Junaida will talk about essential oil in bioplastic film for food packaging. Please welcome Dr. Junaida.
Okay, thank you very much, Dr. Vidi Astuti, for the introduction. So I wish to share my slide, if I may. Can you hear me?
Yes, doctor.
Okay,
You are
then
audible.
good. All right. Okay, can I share my screen? Organizer, can I share my screen? Okay. So first, Assalamualaikum warahmatullahi wabarakatuh. And a very good morning, good day to Dr. Nur Kudus, Dean of Engineering, Universitas Negeri Semarang, and Dr. Prima Astuti Hadayani, Chairperson of this conference, member of organizer, professors, associate professor, doctors, ladies and gentlemen. Okay, first I would like to convey my appreciation to the organizer to invite me to this conference and share my work on essential oil in bioplastic film for food packaging. Okay, next. Okay, this is the outline of my presentation. Current issue on plastic waste, issue on recycled plastic waste, bioplastic and the current demand, bioplastic film for food packaging, turmeric oil as antimicrobial compound in bioplastic film, and finally we look into the conclusion. Next. So first we look into the current issue on world plastic waste. Okay, next. Okay, plastic is a material with very good performance, excellent property. Okay, it's lightweight, easy to form, flexible, not that expensive. Therefore, its application is very wide, from food application to aerospace application. Therefore, demand of plastic year to year increasing. So from this statistic shows that we focus at 2050, there will be a 6 million tons of plastic demand in the world. So, however, to produce plastic, the raw material is about 90% of the raw material is petroleum based. They are non-biodegradable. So therefore, the used plastic or the plastic waste is also non-biodegradable. It's not environmentally friendly, so it's really affect the environment. So what to do? What we have to do on this plastic waste? Next. So this is, we look into the since 1950, where the plastic has been introduced until now. It's about only 9% of the waste plastic being recycled. The balance is dumped in the wild, in a landfill. Okay, and to that, about 4 to 12 million tons of plastic waste end up in river and finally to the oceans. So what happened to this low recycle rate? Okay, so what happened? So what to do? Next slide, please. Thank you. So the issue on recycled plastic waste. What is the problem? Okay, next. Okay, we have a global campaign organized by the government and the non-government bodies on the problem of plastic waste. Campaign on the reuse, recycle, as well as to reduce the use of plastic. So but that is not enough. Management of plastic waste system of a country is very important. So different countries different countries different way of managing the plastic waste. So we look into the recycle rate. For developing country, there are two categories of countries. The first country with regulation on a recycle, and the other category is a developed country with no regulation on recycle. So for a country, developed countries with good with regulation on recycle, they have very good traditional waste infrastructure. They have landfill, proper landfill, they have incinerator. So at the same time, they have organization focus looking at the development of plastic recycle. So with these two conditions, the developed country with regulation on recycle be able to have the recycle rate of 30%. On the other hand, the developed country with no regulation or recycle, the focus is only on good traditional waste infrastructure. They have a landfill, they have incinerator, but the focus is not on recycle. Okay, so this country managed to, the recycle rate is less than 10%. Looking at this low rate, so let's see in developing country. Next slide, please. Thank you. So in developing country, some of the country, they don't have regulation, but the recycle rate very much depends on the motivation of how the high industrial activity. For developing countries, it's categorized to two types, two categories. The countries, developing countries with high industrial activities, and the countries with low industrial activities. For high industrial activity, developing country with high industrial activities, definitely they have inadequate waste management system. The landfill is not properly developed, but the demand or the motivation to recycle is based on the value of the waste. Demand by the company, the recycle company, maybe the plastic recycle company or the metal recycle company. So the motivation on the recycle is based on the demand by these recycle companies. So with this, the developing country with high industrial activities manage to have about 20% recycle rate, okay? But on the other hand, the countries, developing countries with low industrial activity, of course, the infrastructure for waste management is not that sufficient, not that good enough. And then there's no motivation for them to collect plastic waste for recycle because there's no demand from the company, from any recycle company. Therefore, there's no motivation for them to do recycle. So they have zero recycle rate. So looking at this recycle rate, despite of all the global campaign on how to manage plastic waste. So what we have to do next, please. Thank you. So looking at the low recycle rate, something needs to be done, and we want clean beach because due to the low rate of recycle rate, the waste will end up in the river and finally to the ocean and affect the beach. We want clean beach for our vacation. Okay, we have been in our house for almost 1 year. Well, we can go out, especially in Malaysia. We have a very strict MCO. So we want to go to the beach for vacation, but we have to make sure that the beach is clean from waste. Okay, next, please. Okay, to that, bioplastic come into a picture. Okay, so this is one of the way researchers in the world with the problem statement on recycle, on this plastic waste, bioplastic come into a picture. Okay, next. Thank you. So basically, the increasing demand on bioplastic. So look at this chart. There is a sharp increase in the bioplastic demand in year 2017 and 2018. And this shows the impact, the effort of the global campaign on the plastic waste, on the reuse, recycle, and reduce campaign, and the effect from the regulation. So this is a very positive impact. So the campaign has to continue. The regulation has to be continued not only to the developed country, but also the developing country. So what is bioplastic? Okay, bioplastic, bioplastic categorized into two types, the biodegradable and non-biodegradable. So we could see the increase, the orange is in biodegradable. So biodegradable bioplastic derived from waste like agriculture waste, biomass, and renewable sources. Okay, so this is a very bright future for bioplastic with an increased demand. So many things that we can explore on. Okay, next slide, please. So this is on the focusing on the global production capacity for bioplastic in 2019. In 2019, okay, we look at the biodegradable bioplastic. The demand is about 16.4%. And when we look into the biodegradable, the PLO, biodegradable polyester, biodegradable starch blend. So that is the example for starch blend about in 2019 is about 2.4% of the demand. Okay, so we could see that production of global biodegradable bioplastic. So, okay, so next. This is 2019. Now we look into the future of bioplastic. In 2023 is predicted by European Bioplastic 2018. So they forecast that at 2023, there will be a drastic increase in biodegradable demand from 16.4 in 2019 to 49.2% in 2023. So it's a good thing to look. Okay, now when we look into the fraction, the starch blend increases from 2-something to 15.8%. So shows that the demand on bioplastic, especially biodegradable, increasing drastically. So next, please. So this is the segment under the biodegradable plastic. This is the demand, okay? High demand on flexible packaging, okay, 33%, followed by rigid packaging, consumer good, agriculture, coating, textile, electrics, automotive, and others. So we could see that high demand on flexible packaging. Okay, this is the statistic from today, 2020 by the European Bioplastic. Okay, next. So biodegradable flexible packaging is in demand. And when we look, food industry is a very big industry. Everybody eat, okay? So therefore, biodegradable bioplastic film for food packaging is worth to explore. A big area to explore. Okay, so next, please. Thank you. So now we look into biodegradable bioplastic film for food packaging. Okay, next. So in food packaging, okay, the issue that comes is on the food spoilage due to contamination during handling. Therefore, we have to do some improvement to the packaging so that we could prolong shelf life of the food. Okay, so this gives the challenges in developing a bioplastic food for food packaging. First one, the challenge is to produce biodegradable bioplastic, but at the same time with suitable strength, and it's not easy. And then we have to add in the antimicrobial property, the functional property to the bioplastic. And at the same time, it has to be competitive price and the strength, the property has to be equivalent, comparable with the commercial product, so that it can be commercialized and not end up in just a paper publication. Okay, next, that is the challenge that we have to look into. To solve the challenge, okay, on the strength and the biodegradability. So for food packaging, bioplastic film for natural biopolymer for food packaging. We choose for food packaging, we choose, it's good to choose a natural biopolymer. Okay, so these are some of the natural biopolymer that we can use to develop the bioplastic film or bioplastic. We have lipid-based, protein-based, polysaccharide-based, and biocomposites. For detail, we look into the next slide. Okay, for lipid-based bioplastic film, okay, commonly used lipid, the natural polymer are beeswax, carnauba, and shellac wax. Okay, so beeswax is quite expensive then. Okay, now advantage, it has a good barrier, water barrier, but the disadvantages of lipid-based bioplastic film, sometimes it's affect flavor of the food. Okay, and at the same time, lack of homogeneity, brittle. Brittle means poor mechanical property. So this is the advantage or disadvantage of lipid-based bioplastic film. Next. Thank you. Protein-based bioplastic film. Commonly used protein are milk, whey protein, gelatin, soy enzyme protein. Okay, so these are the common natural polymer that we can use. The advantages, good film forming and good gas barrier, but the disadvantage is poor water barrier. Poor water barrier means that the film like water. So when the film like water, the film will be soggy with water. So that is not good to become a bioplastic film. Next. Thank you. So this is polysaccharide-based bioplastic film. So commonly used polysaccharide are agar, alginate, carrageenans, cellulose, chitosan, gum, pectin, and starch. Among these, starch is popular because it's low cost and easily available. And the disadvantage, starch is brittle and poor water barrier. Therefore, with this advantage and disadvantages, we need to do something then, okay, to improve the water barrier and the mechanical strength. Okay, next. All right, with the individual single natural polymer like the lipid, the protein base, and the polysaccharide, they are very sensitive to water. They like water, so it becomes soggy, and then they have very poor mechanical properties. So to solve this, we can combine, okay, combine different natural polymers. Like we combine polysaccharide with protein, we combine polysaccharide with lipid, or we combine polysaccharide with another polysaccharide. So with this blend, it becomes stronger, and we call this biocomposite. So the water barrier property and as well as the mechanical property of the natural polymer will be increases, okay, will be improved. All right, next. Next is, we already mentioned about the biocomposite, how to improve the water barrier and the strength. We look into another issues that we need to counter, which is the microbe, this spoilage, food spoilage. So bioplastic film incorporated with natural antimicrobial compound. For food packaging, it's good to use natural materials. So in this case, we blend the natural biopolymer over the biocomposite with plasticizer and antimicrobial compound in order to form antimicrobial bioplastic film forming solution. First, we have to form solution. So biopolymer can be the biocomposite. The plasticizer is to increase flexibility of the film. And then we add in antimicrobial compound. It's recommended to use the natural product from a plant Okay, and then the solution, the three things will be blend together to form the solution. Okay, next. Okay, now natural antimicrobial compound. There are source of antimicrobial compounds. Common plant, lemongrass, the turmeric, the clove, and even garlic. So different plant has different degree of antimicrobial activity. So we need to explore before use. We need to identify the compound, the functional group suitable for the antimicrobial compound. So antimicrobial or plant with this antimicrobial compound are available around us. So this is a good thing for us to explore. Okay, next. So basically, from the studies state that the generally major groups of antimicrobial compound from plants are phenolic and polyphenol. For detail, we have to investigate the functional group of because the different plant have different specialty compound. Okay, so next. So now this is about we prepare the solution and how to form the film. So film forming for this bioplastic film varies. There are different techniques. The first technique that I want to show you is by this is suitable for it depend. The film techniques depend on its application. So for individual fruits or vegetables, okay. So we have a dipping technique. We have brushed technique, we have spray technique, okay? So for this technique, we have to prepare the solution as what we discussed just now. We need to have the biocomposite, the glycerol or the plasticizer, and the antimicrobial agent from any plant that you want, okay? So, and then you dip your fruits, for example, or dip, spray, or brush. For example, you want to deep apple, as you know, for preservation, apple is coated with wax to make it shelf life longer and to make it look shiny, but we don't know what wax that they are using. So for a very green technique, green solution, we can use this film solution to coat the apple or any vegetables, and this solution can be used in post-harvesting time. So it will be benefit to the agriculture field. Okay, maybe we can replace the solution, the chemical that they use to preserve the vegetables or the fruits before they deliver to the consumer. So in this technique, what we have to do is just dip, spray, or brush the fruits or the vegetables, and then let it evaporate, and then it ready for the ready to be distributed to the consumer. So this is one of the way, and I think this is a good thing that we can explore for agriculture. Okay, next. Another technique is film forming, film casting. Okay. So in laboratory, what we do is just we pour the solution that we prepare just now onto a plate, okay, and then we let it dry in oven at certain temperature for a few hours, and then we let it cool, and we can use the film for characterization and for application. Whereas in industry, we use similar step, which is to pour the solution into the substrate, moving substrate, and then it will go to drying and then finally being rolled and ready for use. Okay, so this is about film casting. Next. Thank you. So this is a film forming technique on paper. So this is for paper packaging for food is paper wrapping. Okay, normally we have film on top of the paper to wrap, like in Malaysia, we wrap nasi lemak using the paper. So the glossy paper will be inside so that there will be no, the paper will not be soggy, okay? So one of the techniques, there are several techniques, whether we can dip the paper into the solution, polymer solution, or we spread it on a rolling paper moving, we spread the film, okay, and then or you using extruded film, and we place it onto the moving paper, or we roll it. So this some of the techniques that we can use. Next, please. Okay, so after forming the film forming, we need to do characterization of the bioplastic film to make sure that the film that we produce is suitable for the application. All right, so what is the important characterization that we can do? We should do. Next. So physical property is very important. Objective of physical property, to know about the physical property, to know the water barrier property of the film that we produce. By looking at, we could look at the what thickness, water surface analysis, the weight loss, and surface morphology. Okay, so that is very important, because from the physical property we know that water barrier of the film is good enough and comparable with the commercial product. So next, please. So another important properties, of course, it's strength. Okay, we produce a film with a good strength suitable for the food packaging. Okay, next. Another properties that we need to know, to measure, to justify that the film that we produce is good is on inhibition zone. Inhibition zone means that the ability this is a bacteria or a microbe inhibition zone. So the ability of the film to control growth of bacteria, or the ability of the film to protect our food from spoil. So that is very important property or test that we have to do. And then, of course, the biodegradable test. We can't claim that the film that we produce is biodegradable unless we test on the biodegradability of the film. Okay, so biodegradability test is we bury the film into soil for a certain time. So okay, we will discuss it later. And beside that, the sensory test, the shelf life, the toxicity test is another important test that we have to perform, since this product is for food packaging. Okay, next, please. So now turmeric oil as antimicrobial compound in bioplastic film. Okay, next. So I wish to share one of my finding, our group finding, my team finding, on response surface methodology analysis toward biodegradability and antimicrobial activity of bioplastic film containing turmeric oil against Aspergillus niger. Okay, so for this work, we coat or we spread film solution into a paper, a craft paper. Okay, we want to produce paper packaging with film, thin film on top of the paper for food packaging. Okay, so next, please. For this work, we use biocomposite natural polymer, a combination of cassava starch and the carboxylate methyl cellulose, CMC. Okay, both of it is polysaccharide. From the research, we found out that combining these two will produce a very good, strong film. Okay, we add in glycerol to improve flexibility of the film. We add in turmeric oil. We extract the turmeric oil from the fresh turmeric using hydrodistillation technique. Okay, and then for the foaming solution, we mix together or blend together CS solution, CMC solution together with glycerol and different amount of turmeric. For detailed methodology, maybe you can refer to my paper. So then the blended solution we form through casting, okay, casting technique, whereby we cast the solution onto the craft paper. Okay, the craft paper that we bought is non-glossy also, and then we heat it and we cool it down for the analysis. Okay, next. For this work, we look into variables. We look at the effect of film thickness and volume of turmeric oil. We vary the film thickness and the volume of turmeric oil, and we want to look into the antimicrobial agent release. Okay, it means that we want to know how the turmeric oil released to the food. Okay, so what we did is we cut the film and we place it in distilled water. The distilled water will simulate the food juice. Okay, so we will soak the film, the biofilm that we produce in distilled water for about 2 hours. Okay, and then after that we measure the concentration of turmeric oil in the solution. So from that we be able to determine how the amount of released turmeric oil with different thickness and different amount of turmeric oil. Okay, next we do the, sorry, not yet. Okay, sorry, the inhibition zone for Aspergillus niger. So what we did is we cut the sample into pieces, and then we place the film in the agar plate, which is spreaded by Aspergillus niger. So we leave it for 3 days, and then we look how the Aspergillus niger grow. So we look into the clean zone, what is the radius, what is the size, how the turmeric oil be able to stop the Aspergillus growth. Okay, and then finally we perform the biodegradation test. In biodegradation test, we cut the sample and we buried it in soil, okay, for 3 months, open environment with rains and sun for 3 months, and then we measure the weight difference to see the biodegradability of the film. Okay, next please. Thank you. So this is the result. Different thickness, different turmeric volume. So we have a different percent of antimicrobial agent release. And then we have different inhibition zone, the weight, okay? And then we have different biodegradation weight loss. So if I may share one at with thickness of 0.5 millimeter with amount of 30 microliter, the biofilm managed to biodegrade in soil about 76.45%. Okay, so this is shows that this film be able to degrade and be able to inhibit the growth of Aspergillus, and at the same time release, the inhibition is based on the release of the turmeric oil. Okay, next please. So this is the inhibition zone test. Okay, the clear area shows the ability of the film to block the growth of Aspergillus niger. Okay, so different thickness and different amount of turmeric oil. Okay, A, B, C, and D. Next. So this is a response surface plot. We could see the relationship between the thickness and the amount of turmeric oil on the release of turmeric oil, the inhibition zone, as well as the biodegradability of the film. Next. So this is the finding that we found, that film thickness and amount of turmeric oil gives significant impact with the antimicrobial and biodegradation properties of the bioplastic film. Okay, but not to forget the importance of water barrier and mechanical properties. So water barrier and mechanical properties is not reported in my paper, but anyway, we compare for the water barrier and mechanical property, we compare our product with the commercial product. The commercial wrapping paper, the film laminated paper in the market. So we compare because we want to make sure that the film that we produce can be used by the consumer. And we found that the water barrier and the mechanical properties almost comparable. So it's good to use the commercial product as a reference for us to design our formulation, so that the formulation that we produce can be used by the consumer. Okay, it can be it can be marketable. Okay, so that is my tips. Okay, next. So recommendation for the work, maybe a collaboration with anyone here who want to explore on this area. So essential oil is volatile compound. Okay, we know that. Maybe this make there will be a leakage of essential oil from the film, not during the application, but during the storage. Okay, so maybe it will the efficiency of the film will be reduced. Efficiency of the antimicrobial film will be reduced. So therefore, this is something that we can explore. Kinetic release of essential oil from bioplastic film is another area. Maybe we can expose the or place the plastic film in different environment. Okay, so to stimulate the storage or to simulate the use of the application of the essential of the film. Okay, another topic that we can explore is the encapsulated essential oil in bioplastic. It's another interesting topic to be investigated. So by encapsulating the essential oil, we can control release the essential oil. So we can control the life or the shelf life of the film, even during the storage and during the application. Okay, next. So I come to a conclusion. Next. So future of bioplastic. Market demand on bioplastic is increasing. Okay. And natural resources are abundant around us. Especially we are blessed with all the plants that we have, and regulation by the authorities, readiness of the industries, and awareness of the consumer give the final say to bioplastic. Or otherwise, our research on bioplastic will end up in a published paper or only in thesis, and does not give benefit to the society. Okay, thank you. Next. With that, I thank you. Yes, Dr. Widi.
Okay, thank you for your talk, Dr. Junaida. It's a very interesting topic. We will get back to you after the presentation from the second speaker. Okay.
Okay, thank you.
Okay. Now moving along to second speaker, please welcome Professor Dr. Waradiah Pitarengga, who will be speaking to us on activated carbon-based slow-release fertilizer for crop production. Dr. Waradiah Pitarengga is a professor in Chemical Engineering Department, Faculty of Engineering, Universitas Negeri Semarang. Her bachelor's degree was obtained from Chemical Engineering, Universitas Diponegoro, while her master and doctoral degree were obtained from Universitas Indonesia. Right now, she focuses on biomaterials. She has published more than 20 Scopus Index articles. In addition, several articles have been published in a couple of conferences which were held in France, Japan, Spain, England, and Vietnam. She has 2 national patents, 1 trademark, and 2 industrial designs. Current position as a group leader at the Quality Guarantor for Research and Public Service of Universitas Negeri Semarang. Professor Dr. Waradiah Pitarengga, the time is yours.
Okay, thank you, moderator, Ibu Widi Astuti. Good morning, ladies and gentlemen, the Honorable Vice Rector, Academic Affairs, Dean of Engineering Faculty, the Honorable, the speakers, our lecturer, and student. Assalamualaikum warahmatullahi wabarakatuh. First, I would like to express my gratitude to Allah Subhanahu wa Ta'ala for his blessing and mercy that we could assemble in webinar entitled the 10th Engineering International Conference 2021. Thank you for the committee, Ibu Prima Astuti, and now I start to talk about activated carbon-based slow-release fertilizer for crop production. The discussed content in outline, introduction, slow-release fertilizer, features and benefit, and then natural material used for the synthesis of SRF, synthesis of carbon-based SRF, application and performance of carbon-based SRF, and then the last is concluding remark and future perspective. As we know, global food needs are growing over time due to the expected rise in the world's population, and will create a more enormous pressure to enhance crop production to meet food demand. How to strategy to boost agricultural production? Researchers have proposed a number of strategies to bolster agricultural production, and then soil fertilizer is a major barrier to achieve this yield goal. And soil fertilizer management is linked to the type of rate of fertilizer application. To supplement the nutrient deficiencies, researchers have formulated and test numerous fertilizer to maximum crop production, but this fertilizer gradually lose their efficiency with time due to numerous nutrient losses. Poor land management practices and increased use of chemical fertilizers result in solution degradation. So we required improving fertilizer technology and adopting organic farming. For example, in organic fertilizer, nitrogen is lost via fertilization and then leaching, and then denitrification. On the other hand, phosphorus and potassium are lost by fixation, erosion, and runoff. And these losses not only reduce the fertilizer use efficiency about 60%, but also create a major economic and environmental concern. Fertilization plays an important role in crop production with the increased harvest because it affects crop quantity and quality, as well as physical, biological, and psychochemical properties of soil and the quality of groundwater, surface water, and air. Plant nutrient deficiency and soil fertility depletion are the key obstacles to meeting the rising demand for food supply. Consequently, it is necessary to design a new fertilizer formulation to minimize nutrient losses. In this regard, slow-release fertilizer is a hot direction, a new fertilizer development. In the image, we can see a graph of the global consumption of agricultural fertilizer by nutrient from 1965 to 2018. From bottom, nitrogen, and then phosphorus, beta oxide, and the top bottom is potassium oxide. Over time, fertilizer consumption tends to increase with the demand and consumption for nitrogen fertilizer being the highest of all type of the fertilizer. Excessive and insufficient doses of fertilizer, as well as improper fertilization technology, adversely affect the environmental and then quantity and quality of crop. Therefore, the use of fertilizer is indispensable and contributes to about 50% increase in crop year. Fertilizer practices could maintain food production while at some time increases long-term sustainability, reducing environmental impacts and increasing soil organic carbon storage. In the picture, there are two types of curve in the picture showing the time course of plant growth with one application of fertilizer in the form of yellow curve, and then three types of fertilizer application, which is depicted in the three peak of the gray line, show that deliver available plant nutrient continuously over time at predetermined rate is SRF. The other hand, a single application of slow release fertilizer can completely meet a crop nutrient requirement. SRF have become increasing popular in agriculture and attract a great deal of research attention because of their higher efficiency and lower environmental hazard. The main purpose of developing SRF is to improve the quality of conventional fertilizer in order to reduce environmental hazard and wastage of resources. The most important pathway of nutrient release from SRFs are material releasing the nutrients slowly by hindering the solubility. The coating of a fertilizer surface is control rapid release. SRF show a sustained release of nutrient and a good water retention capacity, make SRF a potentially viable tool for agricultural use to save the nutrient resource and labor costs. Slow release fertilizer plays an important role in improving fertilizer use efficiency by plant and by reducing the frequency for fertilization. The other hand, the main limited in the mass application of SRF is their high cost, 2.5 till 8 times compared to conventional fertilizer. Another possible risk could be toxicity of some carrier being used in production of CRF and as advanced manufacturing technology. Besides supplying nutrient, existing SRF use inert carrier material. Therefore, it is important to explore the new climate smart fertilizer to manage nutrient release and simulated crop growth by improving soil quality. In order to increase fertilizer using efficiency, scientists have proposed and test various material to delay the release of nutrients in the table. 3 common methods are used to prepare SRF using chemical compound, coating, or using insert material and matrix type formulation, such as the natural material used for SRF. There is lignin, starch, cellulose, and then many myriad and the mineral for each material uses from the SRF. For example, for the starch, non-toxic, cost efficient, effective, and biodegradable, but the demerits fast degradation and hydrolysis weak coating. But the while the chitosan abundant, no toxic, and biodegradable, but the demerit poor solubility, costly, and toxic. Okay, page 7. Binder for the SRF is also important factor that determine the nutrient release of SRF. Instead, the matrix have shown there are several types of binder, that can be used for SRF production, such as starch, molasses, and ketone. But some other material, such as resin, wax, cellulose, lignin, alginate, starch, ketone, is used to synthesis SRF. But some there's any researcher say that material could be toxic, inefficient, costly, fast degraded, poor coating, and low solubility. And then recently, there has been a significant interest in the research for the development of SRF while using the bio-based polymer as coating material, such as starch, lignin, cellulose, and bio-based polyurethane. This material is not suitable for the production SRF unless modified with a suitable cross-linker, plasticizer, or stabilizer due to their poor mechanical and thermal physical properties. It is very crucial. So how about the inorganic and natural fertilizer? Okay, back to the SRF. SRF are recommended only for higher value agricultural field. According to the research effort, must focus on the exploration of cost-effective and efficient material and techniques that can be SRF common farmers in order to harvest benefit without economic losses. In order to produce a low-cost SRFs, new material from local area should be tested using ingredients method. There are some engineering challenges and knowledge gaps which require further attention to make this approach more convenient and beneficial. Okay, and the picture, the product of SRF, carbon-based material such as biochar and activated carbon as fertilizer, nutrient carriers. Next, in the picture already, schematic illustration of carbonous material preparation, steam activation, and silica remove process. And then, okay. Activated carbon as carrier of fertilizer should be made by trial as shown in the material rice husk was synthesis by physical activation and silica remove process. The carbonized rice husk were comminuted and activated with a steam to enhance the activation effect. In addition, a steam injection time to control to identify the effect of the activation time. After the activation, sample were washed by the ionic water to remove impurified until neutralized. So this is a process that prepare to make carbonous material from rice husk. Okay, and the picture again. The analysis of the infrared spectra of highly absorption biochar material prepared under nitrogen atmosphere and then carbon dioxide atmosphere mainly exists many peaks that indicate already functional group in biochar. Comparing the two infrared curve, the absorption peak incentive of biochar material, the two of the gases to prepare the biochar or activity carbon were significantly stronger than CO2 is stronger than nitrogen atmosphere. It indicated that biochar material prepared under CO2 atmosphere had higher surface functional group content because more higher peak for the curve of the infrared, such as what kind of the functional group is hydroxyl group, and then carboxyl group, carbonyl group. Okay, but the main functional group is carboxyl functional group. Carbon-based material for SF. In fertilizer and P potassium. This SRF can be prepared physically by tailoring the properties of carbon-based material to control their nutrient release rate. SRF carrier should be well suited to fertilizer surface property, ought to be hydrophilic, resist to microbial decomposition, improve soil, and then functional group, fast surface area, and porous for nutrient cycle properties. Advantage of cycle absorption of biochar to nutrient. The picture show that wet straw was raised with the ionic water to remove entrant dust and soil, and drying to remove free water. The dried straw was placed in a pyrolysis process, and then under an to prepare initial biochar. The initial biochar is grown and passed through 1 millimeter sieves. After this doing, loading material to biochar such as nitrogen, phosphorus, potassium solution appear in the picture. The biochar particle were uniform coating with layer film coating. After that, obtain the coated carbon-based slow release fertilizer. Schema diagram of carbon-based slow release fertilizer. There is SRF material. The processes is the inside is nutrient core, and then cover with coating. Under influence the soil temperature, moisture penetrate in semi-permeable from the coating and dissolve the nutrient core. The moisture uptake and dissolution of the nutrient core result in building up of osmotic pressure inside the coating, the coat granule, and then second picture, the osmosis pressure causes the nutrient solution to release through a microscopic pore in the coating. And the last, the osmosis pressure causes the nutrient solution is released through microscopic pore in the coating. The nutrients are fully released, all of the nutrient, and the coating disintegrates in soil, degradation and in soil. So for the crop production, some experiment, I take one, for example, the paddy here. We look for on the table shown that the biochar increase the rice yield while lower the methane emission. For example, the toxic for the natural material is toxic is methane. Biochar increase porosity of the paddy soil, which may induce higher soil aeration and oxidation availability. Increasing in rice yield could be related to the increased oxygen available of the soil. As soil aeration is the most important determinant to soil production, and the addition of the biochar increase the soil porosity and aeration. An increasing in oxygen available may accelerate the methane oxidation rate. This proves that the biochar increase the rice yield while decreasing the methane emission. On the explanation above have been explained, starting from the material, process of making activated carbon, coating procedure, and example of use for cropping, as for example paddy. So I go to the conclusion. Number one, the use of SRF is still limited to high value crop, contribute for only 1% of total fertilizer consumption. The expensive coating material carries and the complicated production technique are the main reason for their higher costs. Development of SRF, carbon-based material, especially activated carbon, ability to absorb ammonia, nitrate, potassium, etc., is so well established. The modification of their absorbed by chemical, physical, mechanical, and mineral to improve the surface and structural properties for efficient environment benefit. And then in the future, it is necessary to provide another test in the future and design cost-effective method based on the knowledge provided. Therefore, the development of climate smart and nutrient efficient multivariate SRF. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, thank you very much, Professor Pita, for your interesting topic. Now it is time for question and answer. There are already some questions in the chat box. The first question from Dr. Didik Prastianto for Dr. Junaida. Is there any possibility to combine between natural polymer and synthetic polymer to make biodegradable plastic? If is it possible, how the mixing ratio between the natural and the synthetic polymer?
Okay, can you hear me?
Yes, you are.
Okay. Yeah, thank you very much, Dr. Didik, for the question. Yes, we can mix the natural polymer with synthetic polymer. For example, currently I and my team doing research on the production of this poly bag, biodegradable poly bag for plant, the black in color. So we use a combination of polyethylene and starch. Okay, so definitely yes, you have to choose the right ratio, and we can start the ratio with 70 to 30, 70% PE and 30% starch. Okay, when PE when combined with starch, the property will be different. So there is no longer individual PE, it becomes different structure. Therefore, it can be degraded. From my study, roughly with 70% of PE and 30% of the starch, will be able to roughly biodegrade the film around 40 to 50% within 3 months. So that is the so shows that when we reduce the amount of synthetic polymer, the percentage of reduction will be increased. However, the ratio has to be set up based on the application. So if you want the film to be strong, it has to be high in PE. Okay. So therefore we have to have our reference. What is our reference, the product that we want to produce? So that is actually the target in our design on the ratio of the synthetic polymer and the natural polymer. So I hope this will answer the question. Okay.
Thank you very much, Dr. Junaida. The next questions for Dr. Junaida from Mr. Suhriyan Diki. We know that bioplastics are more friendly to the environment. I want to ask, how long does bioplastic take time to degrade in soil or water? And the second question, because the bioplastic was made through casting plate, how the fabrication system if we want to use as plastic bag?
Okay, all right, thank you, Dr. Zuhriyan, okay, for the question. Okay, the first question, the times. Okay, the degradability of the bioplastic very much depends on the thickness of the film, okay, and the formulation. As what I just mentioned just now, if you use a combination of natural and synthetic, so that is the gauge, and then the thickness. From in my study, the one that I cast, which is the flexible biofilm, for 20 millimeter thickness, 2 millimeter thickness is about 50% reduction in within 3 months. Okay, so if the film reduce the thickness to 0.5 mm, the reduction will increase. It's about 76% reduction in within 3 months. So that is the how it can relate the degradation time, thickness, and the formulation. In terms of the other question, okay, the one that I will produce is through casting film. This is suitable for flexible film, suitable for wrapping paper wrapping. We want to wrap a very thin film to wrap fruits or bread. Okay, so for the casting, for the plastic bag, the formulation may be slightly different. We need tougher, stronger film. So what we can do, the fabrication technique to produce plastic bags, we can use blown extrusion plastic film. So we have to produce, we need to produce resin. Okay, so maybe we can use a combination of the synthetic, which is PE and starch, combine it together, and then we mix together, we produce the resin, we inject to the extruder, and we blow to form the plastic film. Okay, so that is one of the way to produce plastic bag. So again, formulation varies with application. So and then I hope I answer the question. Dr. Zurian. Okay, all right, next question.
Okay, thank you very much, Doctor, for your explanation. And the next question from Dr. Australia. What are the most influential for the manufacture of antimicrobial bioplastic? Does the application also include material for consideration for making bioplastics?
Okay, thank you very much, Dr. Australia. So the question asked me about influential factor, I think, in manufacturing the microbial bioplastic. The most important thing is our target, what we want to produce. That is the main thing. You want to produce a very flexible, simple film like I produce. The formulation will be different. If you want to film tougher strength, okay, it will be different. So therefore, the important factor is to choose the right ratio of materials, the polymer, the plasticizer, or any additive, the right ratio. Okay, and then of course, the right material for the application. So that is the three things: material, ratio, and standard. What is the application that you want to use? That will be the important factor that you want that we can look into. Okay, so I hope that will answer the question.
Thank you very much, Doctor. And the next questions for Professor Pita from Harry Rustamaji. Biochar usually has higher functional group than activated carbon, but less the specific surface area. What is more the important properties to fulfill requirement for SRI?
For the unorganic, yes. Okay, thank you, moderator. This question, what is this question? Functional group from the activated carbon is more important from the to attach from the fertilizer, because after we take off the carbon, the depend of the pore and then surface area and the so final group, so functional group. So the all of them factor is should be suitable for the fertilizer. There is an inorganic fertilizer is sometimes is unorganic, and then after we take diameter of the fertilizer is suitable for the carbon, and then the second is the surface area. If there is more surface area is highly, maybe the nutrient can attach from the activated carbon. So then functional group, functional is to make the condition, because the acid condition maybe should make the what is the functional group is can be used for the fertilizer. Okay, thank you, Ibu Moderator.
Thank you, Prof. Pita, for your explanation. And the last question, maybe. For Prof. Pita from Naila Hoirina. Okay, Prof. Pita, it has been explained previously that SRF is the best solution and has provided various advantage. When compared to other fertilizers such as conventional fertilizers without coatings, as well as inorganic fertilizer, what percentage effectiveness does activated carbon-based SRF provide in the release of nutrients?
Very long question. Okay, thank you. I think the core of the question is the comparison of the inorganic fertilizer and then organic fertilizer and SRF. Okay. Firstly, inorganic fertilizer is a type fertilizer derived containing nutrient or mineral. Maybe some people say that say chemical fertilizer for inorganic fertilizer, such as urea, NPK is an organic fertilizer. And then organic fertilizer is a natural material such as green matter, and then some of biomass cover on the crop or landfill is also as a fertilizer, but the small or low nutrient. Animal mature also and compost are organic in nature, are slowly decomposed by microbial activity for organic. But the unorganic fertilizer is have a strong soluble to water, resulting in a low fertilizer effectively compared to organic, because organic is very slow, depend on the microbial activity. So SRF is the middle, organic and unorganic. So the SRF is can delay nutrient soluble after maybe the soil of the plant is watering, and then very small nutrient but continues to diffuse from the soil. So this is very effective for the SRF, depend on organic and organic fertilizer. Thank you. Thank you, Ibu Moderator.
Okay, I'm sorry. Thank you, Prof. Pita. The last question for Prof. Pita from Mr. Bayu Triwibowo. How can we assess the effectiveness of SRF in the plants and soil?
Mana Pak pertanyaannya sebentar?
Can I add my question? So
Direct,
my core question is actually if even when it's nice to we control the nutrient to release towards the plant and soil, but it doesn't close the possibility of over fertilizer, because if the fertilizer is slow release, it will increase the risk of the accumulation of chemical substance in the soil if it doesn't release properly. If we have such a phenomena that called over fertilization, how we troubleshoot this kind of phenomena if we use slow release fertilizer, because it doesn't close the possibility that the compound of the fertilizer will release as we plan to release towards our crops.
Okay, thank you very much. For SRF is with the release slow fertilizer to soil. But sometimes a direct inorganic fertilizer is I think it's more accumulation the soil, and then something the soil is hardened, maybe too much from the phosphorus, so make the kesuburan tanah itu akhirnya dia decrease. So to make I think SRF is very important, because after nutrient release from the soil, and then a plant put the nutrient, so make to grow, and then the accumulation from the soil is, I think, is not too much. So I think it's efficient for the plant and application, and then also this not make trouble or make the minute of the soil like this. Mr. Bayu.
Okay. Is it clear, Mr. Bayu? Okay, thank you very much, Prof. Pita. I think the time is running out. If you have any questions, you can connect directly with the speaker. At the end of this session, we can conclude that bioplastic is an alternative to solve the plastic waste issue due to it is environmentally friendly. However, the development of bioplastic depends on the regulation, readiness of industries, and consumer awareness. On the other side, carbon-based materials can serve as nutrient carriers for formulating climate-smart and cost-effective slow-release fertilizer. Okay, the next event is the awarding of certificates to the two speakers, Dr. Junaidah and Professor Dr. Waradiah Pitarengga. Please stay with us.
And before we go to the next agenda, I would like to invite the Dean of Engineering Faculty, Dr. Nurkudus MT IPM, to virtually give the certificate to the each keynote speakers. From the first keynote speakers, Dr. Junaidah Jai.
Okay, thank you very much. We truly appreciate your participation as our keynote speaker today. There is a certificate for you, Professor Madya, Dr. Junaidah Jai, from School of Chemical Engineering, College of Engineering, University Technology Mara, Malaysia. Thank you very much, Prof. Junaidah.
And for the second keynote speakers from the second session, Professor Dr. Waradiah Pitarengga, STMT.
Okay, thank you very much for your presentation, Prof. Waradiah Pitarengga from Chemical Engineering. Universitas Negeri Semarang. There is a certificate as a token of appreciation. Thank you very much, Prof. Gita.
Thank you. On behalf of all committees, I would like to thank Dr. Junaida and Professor Dr. Waradiah Pitarengga for addressing this interesting topic. To all participants, thank you for your attention. I am truly sorry if there are any mistaken words. We hope you and your family are all safe, healthy, and doing as well in the face of this global pandemic. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much. That was a great presentation. Well, ladies and gentlemen, that was the last presentation of our keynote speakers. Next, we are going to have a break time, then continue to the parallel session. During the break time, you are not allowed to leave the Zoom room because at the end, there will be an important announcement. We are going to break down the presenter into 9 rooms as scheduled. So make sure you have required Zoom account name. Thank you. See you on the closing event. Kepada Bapak dan Ibu presenter sekalian, selamat istirahat. Kami mohon untuk tidak meninggalkan meeting room. Kami akan membagi presenter menjadi 9 ruangan sesuai dengan yang sudah dijadwalkan. Silahkan klik join ketika muncul notifikasi untuk masuk ke ruangan masing-masing. Kami juga menghimbau untuk dapat memastikan nama akun Zoom Bapak dan Ibu sekalian agar sesuai dengan petunjuk yang diberikan panitia. Dan kami mohon untuk tidak meninggalkan ruang Zoom hingga acara selesai. Terima kasih.
Akan ada masa di mana kita menjalin rasa manusia dengan semesta. Kan banyak arti dalam setiap langkah yang terlewati. Bercerita lewat asa untuk terus dijaga.
Manusia sejatinya berencana, menata cita-cita dalam bingkai rencana. Percaya bahwa keindahan tercipta bukan instan, melainkan lewat prinsip dan pedoman. Kreativitas dan imajinasi saling berkolaborasi, mengasah naluri, menjamah potensi. Tak akan bertemu ujung untuk apa yang kami kejar. Tak akan tercipta rasa tanpa belajar. Apa yang kami lakukan berawal dari sebuah ilmu yang kami emban di rumah peradaban, Universitas Negeri Semarang.
Kemajuan kita sebagai bangsa tidak bisa lebih cepat daripada kemajuan kita dalam pendidikan. Pikiran dan wawasan menjadi sumber daya fundamental.
Di sini saya belajar banyak hal, seperti mempertajam kecerdasan, memperkukuh kemauan, dan memperhalus perasaan.
Pendidikan adalah senjata paling ampuh untuk mengubah dunia, termasuk Indonesia. Berangkat dari mana? Dari diri kita sendiri.
Inilah rumah ilmu pengembang peradaban, tempat tunas penuh talenta tumbuh bermekaran dalam kasih sepenuh hati, bertumbuh menemu arti. UNES Gemilang untuk Indonesia Maju.
Kegemilangan memandu UNES dalam melahirkan generasi berkarakter dan berprestasi, agar tunas muda Indonesia bertumbuh, menemukan peran dan makna demi kejayaan Indonesia dalam peradaban dunia.
Setia mengawal semangat perubahan demi kemajuan bangsa dan peradaban, sebab kami percaya niat baik saja tak cukup. Denyut inovasi harus terus berdegup. Arum luhuring pawiyatan ing astoniro, semangat ini berdiam di hati, terpatri di jiwa kami.
Selamat datang di Universitas Negeri Semarang.
Gemilang untuk Indonesia Maju.
Selamat datang di Universitas Negeri Semarang. Gemilang untuk Indonesia Maju.
Akan ada masa di mana kita menjalin rasa manusia dengan semesta. Mendaki ke puncak tertinggi, menggapai tujuan dengan kerja keras dan strategi. Perjalanan mengajarkan banyak arti dalam setiap langkah yang terlewati. Bercerita lewat asa untuk terus dijaga.
Manusia sejatinya berencana, menata cita-cita dalam bingkai rencana. Percaya bahwa keindahan tercipta bukan instan, melainkan lewat prinsip dan pedoman. Kreativitas dan imajinasi saling berkolaborasi, mengasah naluri, menjamah potensi. Tak akan bertemu ujung untuk apa yang kami kejar. Tak akan tercipta rasa tanpa belajar. Apa yang kami lakukan berawal dari sebuah ilmu yang kami emban di rumah peradaban, Universitas Negeri Semarang.
Kemajuan kita sebagai bangsa tidak bisa lebih cepat daripada kemajuan kita dalam pendidikan. Pikiran dan wawasan menjadi sumber daya fundamental.
Di sini saya belajar banyak hal, seperti mempertajam kecerdasan, memperkukuh kemauan, dan memperhalus perasaan.
Pendidikan adalah senjata paling ampuh untuk mengubah dunia, termasuk Indonesia. Berangkat dari mana? Dari diri kita sendiri.
Inilah rumah ilmu pengembang peradaban, tempat tunas penuh talenta tumbuh bermekaran dalam kasih sepenuh hati, bertumbuh menemu arti. UNES Gemilang untuk Indonesia Maju.
Kegemilangan memandu UNES dalam melahirkan generasi berkarakter dan berprestasi, agar tunas muda Indonesia bertumbuh, menemukan peran dan makna demi kejayaan Indonesia dalam peradaban dunia.
Setia mengawal semangat perubahan demi kemajuan bangsa dan peradaban, sebab kami percaya niat baik saja tak cukup. Denyut inovasi harus terus berdegup. Arum luhuring pawiyatan ing astoniro, semangat ini berdiam di hati, terpatri di jiwa kami.
Selamat datang di Universitas Negeri Semarang.
Gemilang untuk Indonesia maju.
Selamat datang di Universitas Negeri Semarang. Gemilang untuk Indonesia maju.
Akan ada masa di mana kita menjalin rasa manusia dengan semesta. Mendaki ke puncak tertinggi, menggapai tujuan dengan kerja keras dan strategi. Perjalanan mengajarkan banyak arti dalam setiap langkah yang terlewati. Bercerita lewat asa untuk terus dijaga.
Manusia sejatinya berencana, menata cita-cita dalam bingkai rencana. Percaya bahwa keindahan tercipta bukan instan, melainkan lewat prinsip dan pedoman. Kreativitas dan imajinasi saling berkolaborasi, mengasah naluri, menjamah potensi. Tak akan bertemu ujung untuk apa yang kami kejar. Tak akan tercipta rasa tanpa belajar. Apa yang kami lakukan berawal dari sebuah ilmu yang kami emban di rumah peradaban, Universitas Negeri Semarang.
Kemajuan kita sebagai bangsa tidak bisa lebih cepat daripada kemajuan kita dalam pendidikan. Pikiran dan wawasan menjadi sumber daya fundamental.
Di sini saya belajar banyak hal, seperti mempertajam kecerdasan, memperkukuh kemauan, dan memperhalus perasaan.
Pendidikan adalah senjata paling ampuh untuk mengubah dunia, termasuk Indonesia. Berangkat dari mana? Ya dari diri kita sendiri.
Inilah rumah ilmu pengembang peradaban, tempat tunas penuh talenta tumbuh bermekaran dalam kasih sepenuh hati, bertumbuh menemu arti. UNES Gemilang untuk Indonesia maju.
Kegemilangan memandu UNES dalam melahirkan generasi berkarakter dan berprestasi, agar tunas muda Indonesia bertumbuh menemukan peran dan makna demi kejayaan Indonesia dalam peradaban dunia.
Setia mengawal semangat perubahan demi kemajuan bangsa dan peradaban. Sebab kami percaya niat baik saja tak cukup. Denyut inovasi harus terus berdegup. Arum luhuring pawiyatan ing astoniro. Semangat ini berdiam di hati, terpatri di jiwa kami.
Selamat datang di Universitas Negeri Semarang.
Gemilang untuk Indonesia maju.
Selamat datang di Universitas Negeri Semarang. Gemilang untuk Indonesia maju.
Akan ada masa di mana kita menjalin rasa manusia dengan semesta. Mendaki ke puncak tertinggi, menggapai tujuan dengan kerja keras dan strategi. Perjalanan mengajarkan banyak arti dalam setiap langkah yang terlewati. Bercerita lewat asa untuk terus dijaga.
Manusia sejatinya berencana, menata cita-cita dalam bingkai rencana. Percaya bahwa keindahan tercipta bukan instan, melainkan lewat prinsip dan pedoman. Kreativitas dan imajinasi saling berkolaborasi, mengasah naluri, menjamah potensi. Tak akan bertemu ujung untuk apa yang kami kejar. Tak akan tercipta rasa tanpa belajar. Apa yang kami lakukan berawal dari sebuah ilmu yang kami emban di Rumah Peradaban, Universitas Negeri Semarang.
Kemajuan kita sebagai bangsa tidak bisa lebih cepat daripada kemajuan kita dalam pendidikan. Pikiran dan wawasan menjadi sumber daya fundamental.
Di sini saya belajar banyak hal, seperti mempertajam kecerdasan, memperkukuh kemauan, dan memperhalus perasaan.
Pendidikan adalah senjata paling ampuh untuk mengubah dunia, termasuk Indonesia. Berangkat dari mana? Ya dari diri kita sendiri.
Inilah Rumah Ilmu Pengembang Peradaban, tempat tunas penuh talenta tumbuh bermekaran dalam kasih sepenuh hati, bertumbuh menemu arti. UNES Gemilang untuk Indonesia Maju.
Kegemilangan memandu UNES dalam melahirkan generasi berkarakter dan berprestasi, agar tunas muda Indonesia bertumbuh, menemukan peran dan makna demi kejayaan Indonesia dalam peradaban dunia.
Setia mengawal semangat perubahan demi kemajuan bangsa dan peradaban, sebab kami percaya niat baik saja tak cukup. Denyut inovasi harus terus berdegup. Arum luhuring pawiyatan ing astoniro, semangat ini berdiam di hati, terpatri di jiwa kami.
Selamat datang di Universitas Negeri Semarang.
Gemilang untuk Indonesia Maju.
Selamat datang di Universitas Negeri Semarang. Gemilang untuk Indonesia Maju.
Akan ada masa di mana kita menjalin rasa manusia dengan semesta. Mendaki ke puncak tertinggi, menggapai tujuan dengan kerja keras dan strategi. Perjalanan mengajarkan banyak arti dalam setiap langkah yang terlewati. Bercerita lewat asa untuk terus dijaga.
Manusia sejatinya berencana, menata cita-cita dalam bingkai rencana. Percaya bahwa keindahan tercipta bukan instan, melainkan lewat prinsip dan pedoman. Kreativitas dan imajinasi saling berkolaborasi, mengasah naluri, menjamah potensi. Tak akan bertemu ujung untuk apa yang kami kejar. Tak akan tercipta rasa tanpa belajar. Apa yang kami lakukan berawal dari sebuah ilmu yang kami emban di Rumah Peradaban, Universitas Negeri Semarang.
Kemajuan kita sebagai bangsa tidak bisa lebih cepat daripada kemajuan kita dalam pendidikan. Pikiran dan wawasan menjadi sumber daya fundamental.
Di sini saya belajar banyak hal, seperti mempertajam kecerdasan, memperkukuh kemauan, dan memperhalus perasaan.
Pendidikan adalah senjata paling ampuh untuk mengubah dunia, termasuk Indonesia. Berangkat dari mana? Dari diri kita sendiri.
Inilah Rumah Ilmu Pengembang Peradaban, tempat tunas penuh talenta tumbuh bermekaran dalam kasih sepenuh hati, bertumbuh menemu arti. UNES Gemilang untuk Indonesia Maju.
Kegemilangan memandu UNES dalam melahirkan generasi berkarakter dan berprestasi, agar tunas muda Indonesia bertumbuh, menemukan peran dan makna demi kejayaan Indonesia dalam peradaban dunia.
Setia mengawal semangat perubahan demi kemajuan bangsa dan peradaban, sebab kami percaya niat baik saja tak cukup. Denyut inovasi harus terus berdegup. Arum luhuring pawiyatan ing astoniro, semangat ini berdiam di hati, terpatri di jiwa kami.
Selamat datang di Universitas Negeri Semarang.
Gemilang untuk Indonesia Maju.
Selamat datang di Universitas Negeri Semarang. Gemilang untuk Indonesia Maju.
Akan ada masa di mana kita menjalin rasa manusia dengan semesta. Mendaki ke puncak tertinggi, menggapai tujuan dengan kerja keras dan strategi. Perjalanan mengajarkan banyak arti dalam setiap langkah yang terlewati. Bercerita lewat asa untuk terus dijaga.
Manusia sejatinya berencana, menata cita-cita dalam bingkai rencana. Percaya bahwa keindahan tercipta bukan instan, melainkan lewat prinsip dan pedoman. Kreativitas dan imajinasi saling berkolaborasi, mengasah naluri, menjamah potensi. Tak akan bertemu ujung untuk apa yang kami kejar. Tak akan tercipta rasa tanpa belajar. Apa yang kami lakukan berawal dari sebuah ilmu yang kami emban di Rumah Peradaban, Universitas Negeri Semarang.
Kemajuan kita sebagai bangsa tidak bisa lebih cepat daripada kemajuan kita dalam pendidikan. Pikiran dan wawasan menjadi sumber daya fundamental.
Di sini saya belajar banyak hal, seperti mempertajam kecerdasan, memperkukuh kemauan, dan memperhalus perasaan.
Pendidikan adalah senjata paling ampuh untuk mengubah dunia, termasuk Indonesia. Berangkat dari mana? Dari diri kita sendiri.
Inilah Rumah Ilmu Pengembang Peradaban, tempat tunas penuh talenta tumbuh bermekaran dalam kasih sepenuh hati, bertumbuh menemu arti. UNES gemilang untuk Indonesia maju.
Kegemilangan memandu UNES dalam melahirkan generasi berkarakter dan berprestasi, agar tunas muda Indonesia bertumbuh, menemukan peran dan makna demi kejayaan Indonesia dalam peradaban dunia.
Setia mengawal semangat perubahan demi kemajuan bangsa dan peradaban, sebab kami percaya niat baik saja tak cukup. Denyut inovasi harus terus berdegup. Arum luhuring pawiyatan ing astoniro, semangat ini berdiam di hati, terpatri di jiwa kami.
Selamat datang di Universitas Negeri Semarang.
Gemilang untuk Indonesia maju.
Selamat datang di Universitas Negeri Semarang. Gemilang untuk Indonesia maju.
Akan ada masa di mana kita menjalin rasa manusia dengan semesta. Mendaki ke puncak tertinggi, menggapai tujuan dengan kerja keras dan strategi. Perjalanan mengajarkan banyak arti dalam setiap langkah yang terlewati. Bercerita lewat asa untuk terus dijaga.
Manusia sejatinya berencana, menata cita-cita dalam bingkai rencana. Percaya bahwa keindahan tercipta bukan instan, melainkan lewat prinsip dan pedoman. Kreativitas dan imajinasi saling berkolaborasi, mengasah naluri, menjamah potensi. Tak akan bertemu ujung untuk apa yang kami kejar. Tak akan tercipta rasa tanpa belajar. Apa yang kami lakukan berawal dari sebuah ilmu yang kami emban di rumah peradaban, Universitas Negeri Semarang.
Kemajuan kita sebagai bangsa tidak bisa lebih cepat daripada kemajuan kita dalam pendidikan. Pikiran dan wawasan menjadi sumber daya fundamental.
Di sini saya belajar banyak hal, seperti mempertajam kecerdasan, memperkukuh kemauan, dan memperhalus perasaan.
Pendidikan adalah senjata paling ampuh untuk mengubah dunia, termasuk Indonesia. Berangkat dari mana? Ya dari diri kita sendiri.
Inilah rumah ilmu pengembang peradaban, tempat tunas penuh talenta tumbuh bermekaran dalam kasih sepenuh hati, bertumbuh menemu arti. UNES gemilang untuk Indonesia maju.
Kegemilangan memandu UNES dalam melahirkan generasi berkarakter dan berprestasi, agar tunas muda Indonesia bertumbuh, menemukan peran dan makna demi kejayaan Indonesia dalam peradaban dunia.
Setia mengawal semangat perubahan demi kemajuan bangsa dan peradaban, sebab kami percaya niat baik saja tak cukup. Denyut inovasi harus terus berdegup. Arum luhuring pawiyatan ing astoniro, Semangat ini berdiam di hati, terpatri di jiwa kami.
Selamat datang di Universitas Negeri Semarang.
Gemilang untuk Indonesia maju.
Selamat datang di Universitas Negeri Semarang. Gemilang untuk Indonesia maju.
Akan ada masa di mana kita menjalin rasa manusia dengan semesta. Mendaki ke puncak tertinggi, menggapai tujuan dengan kerja keras dan strategi. Perjalanan mengajarkan banyak arti dalam setiap langkah yang terlewati. Bercerita lewat asa untuk terus dijaga.
Manusia sejatinya berencana, menata cita-cita dalam bingkai rencana. Percaya bahwa keindahan tercipta bukan instan, melainkan lewat prinsip dan pedoman. Kreativitas dan imajinasi saling berkolaborasi, mengasah naluri, menjamah potensi. Tak akan bertemu ujung untuk apa yang kami kejar. Tak akan tercipta rasa tanpa belajar. Apa yang kami lakukan berawal dari sebuah ilmu yang kami emban di rumah peradaban, Universitas Negeri Semarang.
Kemajuan kita sebagai bangsa tidak bisa lebih cepat daripada kemajuan kita dalam pendidikan. Pikiran dan wawasan menjadi sumber daya fundamental.
Di sini saya belajar banyak hal, seperti mempertajam kecerdasan, memperkukuh kemauan, dan memperhalus perasaan.
Pendidikan adalah senjata paling ampuh untuk mengubah dunia, termasuk Indonesia. Berangkat dari mana? Ya dari diri kita sendiri.
Inilah rumah ilmu pengembang peradaban, tempat tunas penuh talenta tumbuh bermekaran dalam kasih sepenuh hati, bertumbuh menemu arti. UNES Gemilang untuk Indonesia maju.
Kegemilangan memandu UNES dalam melahirkan generasi berkarakter dan berprestasi, agar tunas muda Indonesia bertumbuh menemukan peran dan makna demi kejayaan Indonesia dalam peradaban dunia.
Setia mengawal semangat perubahan demi kemajuan bangsa dan peradaban. Sebab kami percaya niat baik saja tak cukup. Denyut inovasi harus terus berdegup. Arum luhuring pawiyatan ing astoniro. Semangat ini berdiam di hati, terpatri di jiwa kami.
Selamat datang di Universitas Negeri Semarang.
Gemilang untuk Indonesia maju.
Selamat datang di Universitas Negeri Semarang. Gemilang untuk Indonesia maju.
Akan ada masa di mana kita menjalin rasa manusia dengan semesta. Mendaki ke puncak tertinggi, menggapai tujuan dengan kerja keras dan strategi. Perjalanan mengajarkan banyak arti dalam setiap langkah yang terlewati. Bercerita lewat asa untuk terus dijaga.
Manusia sejatinya berencana, menata cita-cita dalam bingkai rencana. Percaya bahwa keindahan tercipta bukan instan, melainkan lewat prinsip dan pedoman. Kreativitas dan imajinasi saling berkolaborasi, mengasah naluri, menjamah potensi. Tak akan bertemu ujung untuk apa yang kami kejar. Tak akan tercipta rasa tanpa belajar. Apa yang kami lakukan berawal dari sebuah ilmu yang kami emban di rumah peradaban, Universitas Negeri Semarang.
Kemajuan kita sebagai bangsa tidak bisa lebih cepat daripada kemajuan kita dalam pendidikan. Pikiran dan wawasan menjadi sumber daya fundamental.
Di sini saya belajar banyak hal, seperti mempertajam kecerdasan, memperkukuh kemauan, dan memperhalus perasaan.
Pendidikan adalah senjata paling ampuh untuk mengubah dunia, termasuk Indonesia. Berangkat dari mana? Ya dari diri kita sendiri.
Inilah rumah ilmu pengembang peradaban, tempat tunas penuh talenta tumbuh bermekaran dalam kasih sepenuh hati, bertumbuh menemu arti. UNES Gemilang untuk Indonesia Maju.
Kegemilangan memandu UNES dalam melahirkan generasi berkarakter dan berprestasi, agar tunas muda Indonesia bertumbuh, menemukan peran dan makna demi kejayaan Indonesia dalam peradaban dunia.
Setia mengawal semangat perubahan demi kemajuan bangsa dan peradaban, sebab kami percaya niat baik saja tak cukup. Denyut inovasi harus terus berdegup. Arum luhuring pawiyatan ing astoniro, semangat ini berdiam di hati, terpatri di jiwa kami.
Selamat datang di Universitas Negeri Semarang.
Gemilang untuk Indonesia Maju.
Selamat datang di Universitas Negeri Semarang. Gemilang untuk Indonesia Maju.
Akan ada masa di mana kita menjalin rasa manusia dengan semesta. Mendaki ke puncak tertinggi, menggapai tujuan dengan kerja keras dan strategi. Perjalanan mengajarkan banyak arti dalam setiap langkah yang terlewati. Bercerita lewat asa untuk terus dijaga.
Manusia sejatinya berencana, menata cita-cita dalam bingkai rencana. Percaya bahwa keindahan tercipta bukan instan, melainkan lewat prinsip dan pedoman. Kreativitas dan imajinasi saling berkolaborasi, mengasah naluri, menjamah potensi. Tak akan bertemu ujung untuk apa yang kami kejar. Tak akan tercipta rasa tanpa belajar. Apa yang kami lakukan berawal dari sebuah ilmu yang kami emban di Rumah Peradaban, Universitas Negeri Semarang.
Kemajuan kita sebagai bangsa tidak bisa lebih cepat daripada kemajuan kita dalam pendidikan. Pikiran dan wawasan menjadi sumber daya fundamental.
Di sini saya belajar banyak hal, seperti mempertajam kecerdasan, memperkukuh kemauan, dan memperhalus perasaan.
Pendidikan adalah senjata paling ampuh untuk mengubah dunia, termasuk Indonesia. Berangkat dari mana? Ya dari diri kita sendiri.
Inilah Rumah Ilmu Pengembang Peradaban, tempat tunas penuh talenta tumbuh bermekaran dalam kasih sepenuh hati, bertumbuh menemu arti. UNES Gemilang untuk Indonesia Maju.
Kegemilangan memandu UNES dalam melahirkan generasi berkarakter dan berprestasi, agar tunas muda Indonesia bertumbuh, menemukan peran dan makna demi kejayaan Indonesia dalam peradaban dunia.
Setia mengawal semangat perubahan demi kemajuan bangsa dan peradaban. Sebab kami percaya niat baik saja tak cukup. Denyut inovasi harus terus berdegup. Arom luhuring pawiyatan ing astoniro. Semangat ini berdiam di hati, terpatri di jiwa kami.
Selamat datang di Universitas Negeri Semarang.
Gemilang untuk Indonesia Maju.
Selamat datang di Universitas Negeri Semarang. Gemilang untuk Indonesia Maju.
Akan ada masa di mana kita menjalin rasa manusia dengan semesta. Mendaki ke puncak tertinggi, menggapai tujuan dengan kerja keras dan strategi. Perjalanan mengajarkan banyak arti dalam setiap langkah yang terlewati. Bercerita lewat asa untuk terus dijaga.
Manusia sejatinya berencana, menata cita-cita dalam bingkai rencana. Percaya bahwa keindahan tercipta bukan instan, melainkan lewat prinsip dan pedoman. Kreativitas dan imajinasi saling berkolaborasi, mengasah naluri, menjamah potensi. Tak akan bertemu ujung untuk apa yang kami kejar. Tak akan tercipta rasa tanpa belajar. Apa yang kami lakukan berawal dari sebuah ilmu yang kami emban di Rumah Peradaban, Universitas Negeri Semarang.
Kemajuan kita sebagai bangsa tidak bisa lebih cepat daripada kemajuan kita dalam pendidikan. Pikiran dan wawasan menjadi sumber daya fundamental.
Di sini saya belajar banyak hal, seperti mempertajam kecerdasan, memperkukuh kemauan, dan memperhalus perasaan.
Pendidikan adalah senjata paling ampuh untuk mengubah dunia, termasuk Indonesia. Berangkat dari mana? Ya dari diri kita sendiri.
Inilah rumah ilmu pengembang peradaban, tempat tunas penuh talenta tumbuh bermekaran, dalam kasih sepenuh hati, bertumbuh menemu arti. UNES Gemilang untuk Indonesia Maju.
Kegemilangan memandu UNES dalam melahirkan generasi berkarakter dan berprestasi, agar tunas muda Indonesia bertumbuh, menemukan peran dan makna demi kejayaan Indonesia dalam peradaban dunia.
Setia mengawal semangat perubahan demi kemajuan bangsa dan peradaban, sebab kami percaya niat baik saja tak cukup. Denyut inovasi harus terus berdegup. Arum luhuring pawiyatan ing astoniro, semangat ini berdiam di hati, terpatri di jiwa kami.
Selamat datang di Universitas Negeri Semarang.
Gemilang untuk Indonesia Maju.
Selamat datang di Universitas Negeri Semarang. Gemilang untuk Indonesia Maju.
Akan ada masa di mana kita menjalin rasa manusia dengan semesta. Mendaki ke puncak tertinggi, menggapai tujuan dengan kerja keras dan strategi. Perjalanan mengajarkan banyak arti dalam setiap langkah yang terlewati. Bercerita lewat asa untuk terus dijaga.
Manusia sejatinya berencana, menata cita-cita dalam bingkai rencana. Percaya bahwa keindahan tercipta bukan instan, melainkan lewat prinsip dan pedoman. Kreativitas dan imajinasi saling berkolaborasi, mengasah naluri, menjamah potensi. Tak akan bertemu ujung untuk apa yang kami kejar. Tak akan tercipta rasa tanpa belajar. Apa yang kami lakukan berawal dari sebuah ilmu yang kami emban di rumah peradaban, Universitas Negeri Semarang.
Kemajuan kita sebagai bangsa tidak bisa lebih cepat daripada kemajuan kita dalam pendidikan. Pikiran dan wawasan menjadi sumber daya fundamental.
Di sini saya belajar banyak hal, seperti mempertajam kecerdasan, memperkukuh kemauan, dan memperhalus perasaan.
Pendidikan adalah senjata paling ampuh untuk mengubah dunia, termasuk Indonesia. Berangkat dari mana? Ya dari diri kita sendiri.
Inilah rumah ilmu pengembang peradaban, tempat tunas penuh talenta tumbuh bermekaran, dalam kasih sepenuh hati, bertumbuh menemu arti. UNES Gemilang untuk Indonesia Maju.
Kegemilangan memandu UNES dalam melahirkan generasi berkarakter dan berprestasi, agar tunas muda Indonesia bertumbuh, menemukan peran dan makna demi kejayaan Indonesia dalam peradaban dunia.
Setia mengawal semangat perubahan demi kemajuan bangsa dan peradaban, sebab kami percaya niat baik saja tak cukup. Denyut inovasi harus terus berdeku. Arum luhuring pawiyatan ing astoniro, semangat ini berdiam di hati, terpatri di jiwa kami.
Selamat datang di Universitas Negeri Semarang.
Gemilang untuk Indonesia Maju.
Selamat datang di Universitas Negeri Semarang. Gemilang untuk Indonesia Maju.
Akan ada masa di mana kita menjalin rasa manusia dengan semesta. Mendaki ke puncak tertinggi, menggapai tujuan dengan kerja keras dan strategi. Perjalanan mengajarkan banyak arti dalam setiap langkah yang terlewati. Bercerita lewat asa untuk terus dijaga.
Manusia sejatinya berencana, menata cita-cita dalam bingkai rencana. Percaya bahwa keindahan tercipta bukan instan, melainkan lewat prinsip dan pedoman. Kreativitas dan imajinasi saling berkolaborasi, mengasah naluri, menjamah potensi. Tak akan bertemu ujung untuk apa yang kami kejar. Tak akan tercipta rasa tanpa belajar. Apa yang kami lakukan berawal dari sebuah ilmu yang kami emban di rumah peradaban, Universitas Negeri Semarang.
Kemajuan kita sebagai bangsa tidak bisa lebih cepat daripada kemajuan kita dalam pendidikan. Pikiran dan wawasan menjadi sumber daya fundamental.
Di sini saya belajar banyak hal, seperti mempertajam kecerdasan, memperkukuh kemauan, dan memperhalus perasaan.
Pendidikan adalah senjata paling ampuh untuk mengubah dunia, termasuk Indonesia. Berangkat dari mana? Ya dari diri kita sendiri.
Inilah rumah ilmu pengembang peradaban, tempat tunas penuh talenta tumbuh bermekaran dalam kasih sepenuh hati, bertumbuh menemu arti. UNES Gemilang untuk Indonesia Maju.
Kegemilangan memandu UNES dalam melahirkan generasi berkarakter dan berprestasi, agar tunas muda Indonesia bertumbuh menemukan peran dan makna demi kejayaan Indonesia dalam peradaban dunia.
Setia mengawal semangat perubahan demi kemajuan bangsa dan peradaban. Sebab kami percaya niat baik saja tak cukup. Denyut inovasi harus terus berdegup. Arum luhuring pawiyatan ing astoniro, semangat ini berdiam di hati, terpatri di jiwa kami.
Selamat datang di Universitas Negeri Semarang.
Gemilang untuk Indonesia Maju.
Selamat datang di Universitas Negeri Semarang. Gemilang untuk Indonesia Maju.
Akan ada masa di mana kita menjalin rasa manusia dengan semesta. Mendaki ke puncak tertinggi, menggapai tujuan dengan kerja keras dan strategi. Perjalanan mengajarkan banyak arti dalam setiap langkah yang terlewati. Bercerita lewat asa untuk terus dijaga.
Manusia sejatinya berencana, menata cita-cita dalam bingkai rencana. Percaya bahwa keindahan tercipta bukan instan, melainkan lewat prinsip dan pedoman. Kreativitas dan imajinasi saling berkolaborasi, mengasah naluri, menjamah potensi. Tak akan bertemu ujung untuk apa yang kami kejar. Tak akan tercipta rasa tanpa belajar. Apa yang kami lakukan berawal dari sebuah ilmu yang kami emban di rumah peradaban, Universitas Negeri Semarang.
Kemajuan kita sebagai bangsa tidak bisa lebih cepat daripada kemajuan kita dalam pendidikan. Pikiran dan wawasan menjadi sumber daya fundamental.
Di sini saya belajar banyak hal, seperti mempertajam kecerdasan, memperkukuh kemauan, dan memperhalus perasaan.
Pendidikan adalah senjata paling ampuh untuk mengubah dunia, termasuk Indonesia. Berangkat dari mana? Dari diri kita sendiri.
Inilah rumah ilmu pengembang peradaban, tempat tunas penuh talenta tumbuh bermekaran dalam kasih sepenuh hati, bertumbuh menemu arti. UNES Gemilang untuk Indonesia Maju.
Kegemilangan memandu UNES dalam melahirkan generasi berkarakter dan berprestasi, agar tunas muda Indonesia bertumbuh menemukan peran dan makna demi kejayaan Indonesia dalam peradaban dunia.
Setia mengawal semangat perubahan demi kemajuan bangsa dan peradaban. Sebab kami percaya niat baik saja tak cukup. Denyut inovasi harus terus berdegup. Arum luhuring pawiyatan ing astoniro, semangat ini berdiam di hati, terpatri di jiwa kami.
Selamat datang di Universitas Negeri Semarang.
Gemilang untuk Indonesia Maju.
Selamat datang di Universitas Negeri Semarang. Gemilang untuk Indonesia Maju.
Akan ada masa di mana kita menjalin rasa manusia dengan semesta. Mendaki ke puncak tertinggi, menggapai tujuan dengan kerja keras dan strategi. Perjalanan mengajarkan banyak arti dalam setiap langkah yang terlewati. Bercerita lewat asa untuk terus dijaga.
Manusia sejatinya berencana, menata cita-cita dalam bingkai rencana. Percaya bahwa keindahan tercipta bukan instan, melainkan lewat prinsip dan pedoman. Kreativitas dan imajinasi saling berkolaborasi, mengasah naluri, menjamah potensi. Tak akan bertemu ujung untuk apa yang kami kejar. Tak akan tercipta rasa tanpa belajar. Apa yang kami lakukan berawal dari sebuah ilmu yang kami emban di Rumah Peradaban, Universitas Negeri Semarang.
Kemajuan kita sebagai bangsa tidak bisa lebih cepat daripada kemajuan kita dalam pendidikan. Pikiran dan wawasan menjadi sumber daya fundamental.
Di sini saya belajar banyak hal, seperti mempertajam kecerdasan, memperkukuh kemauan, dan memperhalus perasaan.
Pendidikan adalah senjata paling ampuh untuk mengubah dunia, termasuk Indonesia. Berangkat dari mana? Dari diri kita sendiri.
Inilah Rumah Ilmu Pengembang Peradaban, tempat tunas penuh talenta tumbuh bermekaran dalam kasih sepenuh hati, bertumbuh menemu arti. UNES Gemilang untuk Indonesia Maju.
Kegemilangan memandu UNES dalam melahirkan generasi berkarakter dan berprestasi, agar tunas muda Indonesia bertumbuh, menemukan peran dan makna demi kejayaan Indonesia dalam peradaban dunia.
Setia mengawal semangat perubahan demi kemajuan bangsa dan peradaban, sebab kami percaya niat baik saja tak cukup. Denyut inovasi harus terus berdegup. Arom luhuring pawiyatan ing astoniro, semangat ini berdiam di hati, terpatri di jiwa kami.
Selamat datang di Universitas Negeri Semarang.
Gemilang untuk Indonesia Maju.
Selamat datang di Universitas Negeri Semarang. Gemilang untuk Indonesia Maju.
Akan ada masa di mana kita menjalin rasa manusia dengan semesta. Mendaki ke puncak tertinggi, menggapai tujuan dengan kerja keras dan strategi. Perjalanan mengajarkan banyak arti dalam setiap langkah yang terlewati. Bercerita lewat asa untuk terus dijaga.
Manusia sejatinya berencana, menata cita-cita dalam bingkai rencana. Percaya bahwa keindahan tercipta bukan instan, melainkan lewat prinsip dan pedoman. Kreativitas dan imajinasi saling berkolaborasi, mengasah naluri, menjamah potensi. Tak akan bertemu ujung untuk apa kami kejar. Tak akan tercipta rasa tanpa belajar. Apa yang kami lakukan berawal dari sebuah ilmu yang kami emban di Rumah Peradaban, Universitas Negeri Semarang.
Kemajuan kita sebagai bangsa tidak bisa lebih cepat daripada kemajuan kita dalam pendidikan. Pikiran dan wawasan menjadi sumber daya fundamental.
Di sini saya belajar banyak hal, seperti mempertajam kecerdasan, memperkukuh kemauan, dan memperhalus perasaan.
Pendidikan adalah senjata paling ampuh untuk mengubah dunia, termasuk Indonesia. Berangkat dari mana? dari diri kita sendiri.
Inilah rumah ilmu pengembang peradaban, tempat tunas penuh talenta tumbuh bermekaran dalam kasih sepenuh hati, bertumbuh menemu arti. UNES Gemilang untuk Indonesia Maju.
Kegemilangan memandu UNES dalam melahirkan generasi berkarakter dan berprestasi, agar tunas muda Indonesia bertumbuh, menemukan peran dan makna demi kejayaan Indonesia dalam peradaban dunia.
Setia mengawal semangat perubahan demi kemajuan bangsa dan peradaban. Sebab kami percaya niat baik saja tak cukup. Denyut inovasi harus terus berdegup. Arum luhuring pawiyatan ing astoniro. Semangat ini berdiam di hati, terpatri di jiwa kami.
Selamat datang di Universitas Negeri Semarang.
Gemilang untuk Indonesia Maju.
Selamat datang di Universitas Negeri Semarang. Gemilang untuk Indonesia Maju.
Akan ada masa di mana kita menjalin rasa manusia dengan semesta. Mendaki ke puncak tertinggi, menggapai tujuan dengan kerja keras dan strategi. Perjalanan mengajarkan banyak arti dalam setiap langkah yang terlewati. Bercerita lewat asa untuk terus dijaga.
Manusia sejatinya berencana, menata cita-cita dalam bingkai rencana. Percaya bahwa keindahan tercipta bukan instan, melainkan lewat prinsip dan pedoman. Kreativitas dan imajinasi saling berkolaborasi, mengasah naluri, menjamah potensi. Tak akan bertemu ujung untuk apa yang kami kejar. Tak akan tercipta rasa tanpa belajar. Apa yang kami lakukan berawal dari sebuah ilmu yang kami emban di rumah peradaban, Universitas Negeri Semarang.
Kemajuan kita sebagai bangsa tidak bisa lebih cepat daripada kemajuan kita dalam pendidikan. Pikiran dan wawasan menjadi sumber daya fundamental.
Di sini saya belajar banyak hal, seperti mempertajam kecerdasan, memperkukuh kemauan, dan memperhalus perasaan.
Pendidikan adalah senjata paling ampuh untuk mengubah dunia, termasuk Indonesia. Berangkat dari mana? Dari diri kita sendiri.
Inilah rumah ilmu pengembang peradaban, tempat tunas penuh talenta tumbuh bermekaran dalam kasih sepenuh hati, bertumbuh menemu arti. UNES Gemilang untuk Indonesia Maju.
Kegemilangan memandu UNES dalam melahirkan generasi berkarakter dan berprestasi, agar tunas muda Indonesia bertumbuh, menemukan peran dan makna demi kejayaan Indonesia dalam peradaban dunia.
Setia mengawal semangat perubahan demi kemajuan bangsa dan peradaban. Sebab kami percaya niat baik saja tak cukup. Denyut inovasi harus terus berdegup. Arum luhuring pawiyatan ing astoniro. Semangat ini berdiam di hati, terpatri di jiwa kami.
Selamat datang di Universitas Negeri Semarang.
Gemilang untuk Indonesia Maju.
Selamat datang di Universitas Negeri Semarang. Gemilang untuk Indonesia Maju.
Akan ada masa di mana kita menjalin rasa manusia dengan semesta. Mendaki ke puncak tertinggi, menggapai tujuan dengan kerja keras dan strategi. Perjalanan mengajarkan banyak arti dalam setiap langkah yang terlewati. Bercerita lewat asa untuk terus dijaga.
Manusia sejatinya berencana, menata cita-cita dalam bingkai rencana. Percaya bahwa keindahan tercipta bukan instan, melainkan lewat prinsip dan pedoman. Kreativitas dan imajinasi saling berkolaborasi, mengasah naluri, menjamah potensi. Tak akan bertemu ujung untuk apa yang kami kejar. Tak akan tercipta rasa tanpa belajar. Apa yang kami lakukan berawal dari sebuah ilmu yang kami emban di rumah peradaban, Universitas Negeri Semarang.
Kemajuan kita sebagai bangsa tidak bisa lebih cepat daripada kemajuan kita dalam pendidikan. Pikiran dan wawasan menjadi sumber daya fundamental.
Di sini saya belajar banyak hal, seperti mempertajam kecerdasan, memperkukuh kemauan, dan memperhalus perasaan.
Pendidikan adalah senjata paling ampuh untuk mengubah dunia, termasuk Indonesia. Berangkat dari mana? Ya dari diri kita sendiri.
Inilah rumah ilmu pengembang peradaban, tempat tunas penuh talenta tumbuh bermekaran dalam kasih sepenuh hati, bertumbuh menemu arti. UNES Gemilang untuk Indonesia Maju.
Kegemilangan memandu UNES dalam melahirkan generasi berkarakter dan berprestasi, agar tunas muda Indonesia bertumbuh menemukan peran dan makna demi kejayaan Indonesia dalam peradaban dunia.
Setia mengawal semangat perubahan demi kemajuan bangsa dan peradaban. Sebab kami percaya niat baik saja tak cukup. Denyut inovasi harus terus berdegup. Arum luhuring pawiyatan ing astoniro. Semangat ini berdiam di hati, terpatri di jiwa kami.
Selamat datang di Universitas Negeri Semarang.
Gemilang untuk Indonesia Maju.
Selamat datang di Universitas Negeri Semarang. Gemilang untuk Indonesia Maju.
Akan ada masa di mana kita menjalin rasa manusia dengan semesta. Mendaki ke puncak tertinggi, menggapai tujuan dengan kerja keras dan strategi. Perjalanan mengajarkan banyak arti dalam setiap langkah yang terlewati. Bercerita lewat asa untuk terus dijaga.
Manusia sejatinya berencana, menata cita-cita dalam bingkai rencana. Percaya bahwa keindahan tercipta bukan instan, melainkan lewat prinsip dan pedoman. Kreativitas dan imajinasi saling berkolaborasi, mengasah naluri, menjamah potensi. Tak akan bertemu ujung untuk apa yang kami kejar. Tak akan tercipta rasa tanpa belajar. Apa yang kami lakukan berawal dari sebuah ilmu yang kami emban di rumah peradaban, Universitas Negeri Semarang.
Kemajuan kita sebagai bangsa tidak bisa lebih cepat daripada kemajuan kita dalam pendidikan. Pikiran dan wawasan menjadi sumber daya fundamental.
Di sini saya belajar banyak hal, seperti mempertajam kecerdasan, memperkukuh kemauan, dan memperhalus perasaan.
Pendidikan adalah senjata paling ampuh untuk mengubah dunia, termasuk Indonesia. Berangkat dari mana? Dari diri kita sendiri.
Inilah rumah ilmu pengembang peradaban, tempat tunas penuh talenta tumbuh bermekaran.